Is the recording on? Are we?
Give it 1 minute. Goes on automatically.
Oh, really?
Oh, automatic recording. Hey, Trimmers. How are you?
Yeah, give it 1 minute so the actual recording time will kick in.
All right.
And then we'll get started.
10, 9, 8. No, okay.
Yeah. Yeah, I wanted it to be about 35. So it'll work. Okay, time to go. Showtime.
All right. It's showtime. Thank you for everyone for coming to the right Kubernetes talk at this time. Josh and I frequently have this problem where we're up against this thing called Kubernetes all the time, and we're
Wait, there's a Kubernetes talk right now?
Yeah.
Hi, see ya.
See ya. So to get on with some disclaimers really quick. Disclaimer, everybody here I'm sure has sat through some kind of mentoring talk. If you're here today, that means it's probably important to you in some way. Things that we're not going to talk about today, because again, this is not your average mentoring talk, but some things that we're going to talk about today, not talk about today, are things like the importance of mentoring, right? Again, you all care about it, you're here. We're not going to talk about the benefits or even how to be a good mentor or mentee. We're really going to hone in on a few things today. Instead, we're going to be talking about the approaches, the techniques, the hot takes, you're in for a good ride, that we've used to tackle the problem of scaling mentoring in open source large-scale projects like Kubernetes. And again, scaling. So you might hear the terms like one-on-one and it doesn't work for us. That doesn't necessarily mean that we don't agree with some of the approaches that we're talking against. It just means from a scale perspective, in the case of Kubernetes with like 40,000 contributors, you might need to scale like hundreds fast, right? So when we say mentoring in Kubernetes, what does that mean to us? That means that we have key roles that we have to fill, most notably member to owner. And I wanted to show this before we really even got into the weeds, because it's important about the terminology that we're going to use today. So in this case, member means you're a part of our GitHub org, and then all the way up to owner means that you are probably in the root owner file, you're merging, approving, doing design work, et cetera. So this is considered our contributor ladder. We have thousands of people who are non-members, and then as the pipeline goes up the hill there to owner, we obviously have only a few hundred owners from a funnel perspective. So we obviously need more people at the top. I'm sure you all need more people at the top wherever you are too. That means people reviewing things. It means people helping you with roadmaps, helping you execute whatever it is. I'm sure you need more people to go up your chain. This is really a chain of trust for us. And as it is in any open source project, really, again, getting maintainership is really about building trust that you're going to take care of the thing and help see it through forward and have it keep innovating. So you'll note the words sponsored, authored, leadership, et cetera, when we talk about like chains of trust. So, with that, let me introduce my co-presenter, Josh Berkus, the illustrious Josh. Many of you might know Josh from his work here at SCaLE, the container track chair, and also PostgreSQL days. Josh is the literal most interesting man on the project in Kubernetes. I promise, sit down with Josh, have a meal, and you'll hear all kinds of stories. Of course, Josh also works at Red Hat in Red Hat's OSPO, holding down open source there.
Cool. And this is Paris, who helped create the Contributor Experience SIG, co-founded the Contributor Experience SIG for Kubernetes. I think you recently stepped down as chair, yeah? recently stepped down as chair, is still the head of the mentoring sub-project for contributor experience. She and I are collaborating on contributor strategy for the CNCF. And she also, in her spare time, does open source strategy things for Google. And as I recently found out in a trip to down to Sunnyvale, San Jose, is really enthusiastic about mini golf. So now, let me actually ask, first I'm going to ask you a question, but I'm actually asking you a preview to this question because I want to get an idea of why people are here. I know some of you, but I don't know all of you. So how many people here are some form of open source project leadership? Okay. How many people have worked on some kind of mentoring program, either within your project, Google Summer of Code, Outreachy, something else? Okay. How many people are in a dev role or community management role in your jobs? Okay, yeah. This is the big thing. Okay. So now I'm going to ask you the question that's to do with our content here, which is, and just shout this out loud, what is the single hardest part of running a mentoring program? What is the thing you have to do to run a mentoring program that is overall your blocker and may in fact cause the mentoring program to not happen?
Quality mentors.
User involvement. You can't put in the participants to actually follow through.
Yeah. Cool. Yep. Actually, those are all definitely hard parts. I'm going to focus on, actually, our first response, which was finding mentors, right? That when I have been unable to make a mentoring program happen, it has been because no mentors are available. It's never because no mentees are available, because it turns out that if your project has any adoption at all, heck, if you can even build programming skills for it, even though the actual software is not popular, there are people out there who are interested in learning how to contribute. But finding mentors is hard. So then the question is, why is finding mentors hard? Again, call it out. Why is it so hard to find qualified mentors to do mentoring, right? We said it before at the beginning, we've actually found that everybody understands that in open source mentoring is important, right? I mean, you do run into some people who don't care. But by and large, if you asked any 10 open source maintainers, 7 or 8 of them would say, yes, mentoring is very important. So if that's overwhelmingly true, why don't more people mentor?
I'm too busy doing everything.
Yep, exactly. It's the time problem. And this is a really hard one. And don't have to take my word for it. We did 2 surveys of Kubernetes contributors that included questions about participation in mentoring programs, and asked people who were at, levels of established contributorship why, if you didn't mentor, why you didn't mentor. And in both surveys, number one reason, which is this teal bar in the middle, was not enough time in the week, ahead of not enough knowledge, which is actually the red one. We're actually going to talk about that one later on, too. But not enough time in the week. And, reason for this is simple, right? Your best mentors are already the busiest people in your project because they know the most and because they're the most in demand, but therefore they also have the least amount of time. So we have 2 problems, right? So we need to solve our not enough mentors problem. In order to solve our not enough mentors problem, we need to solve the time problem. Now, I'm going to criticize something here, which is how most projects do mentoring today. And this is wrong. It is not the solution. And I know it is not the solution because I tried to do it for 15 years and it didn't work. This is what we call informal one-on-one mentoring. And it doesn't work because it doesn't solve the time problem, and as a matter of fact, it makes the time problem worse because you are forcing your biggest contributors to make a choice between mentoring and contributing. Now, let me get specific here what I mean by informal one-on-one mentoring. Informal one-on-one mentoring is a program where you don't have any specific goals or specific time limits. You don't really have structured tasks. You don't have graduation requirements. You just have, hey, this person wants to contribute. Will you please mentor them? And it is how almost every single open source project starts out doing mentoring. Now, which is, the reason why everybody starts out this day is that when your project is really small, like, 4 maintainers, no users in production, a handful of general contributors, etc. When projects are really small, it is really the only thing you can do. You don't have the infrastructure, you don't have anybody managing contributor experience to actually help set up another program, that sort of thing. You don't have, so that is pretty much what you do. And it's probably kind of appropriate for a project of that size. It's kind of like, if you need to go across a creek between 2 meadows, a wooden footbridge is perfectly appropriate. As a matter of fact, building anything more elaborate would be a waste of time. But something really changes as your project gets bigger. Now let me talk about what happens as your project gets bigger. So now a lot of people, when they're looking at the project getting bigger, they kind of focus on things like code base size, right? But the thing is, the code bases, particularly now that we all understand that deleting code is as important as writing code, the code bases don't actually generally grow that fast. Not that much faster than the number of regular contributors, the number of maintainers that you have. That's not really the location of the problem. What grows really fast is, once your project crosses that barrier from being experimental to being useful, your number of users and your number of people who want to become contributors, who are drive-through contributors, who are casual contributors, starts to grow really fast, and a lot faster than your number of maintainers grows. And the thing is, interactions within your project operate as the square of the number of people involved in the project. So your number of issues and your number of pull requests rockets upwards, whereas the number of your maintainers is just growing linearly, generally with the number of project sponsors. So at this point, without even adding a mentoring program, your maintainers are already panicked about their lack of time. And if you get to this point, you are already in big trouble. This is the Minneapolis bridge that collapsed because, they let it keep getting more and more traffic. They kept routing more and more traffic to it over years without ever reevaluating the load on the bridge, and they found out what the actual real load on the bridge was because they exceeded it. And I've seen projects go through this, and it is not any fun at all. You will get nothing done in your project for a year because everything will shut down, and hopefully it won't be permanent. So in order to solve the mentorship program, we need to solve the time problem. As part of mentorship, right, is we cannot have a system of mentorship that makes our maintainers' time problem worse. So now, before I moved over to doing mostly community management, I was doing mostly engineering, particularly worked on database technology for a long time. And one of the things is, how many people here are also programmers? Yeah, just about everybody, right? So if you have a piece of software that's, say, processing data, and it is pegged at 100% CPU, and it's still not processing data fast enough, what do you do with that? We got a whole ton of programmers in the room. What do you do next?
Throw more of the problem.
Throw more what? Right, if you want to make a late project even later. No, what you do is you throw more processes at the problem, right? On a single machine, if you're pegged at 100% CPU on one CPU, then what you need to use is more CPUs. And if one machine is oversaturated, what you need is more machines, right? This is the whole cloud thing, Hey, we want to scale out and not just try to scale up. And so we need to do the same thing with mentoring, right? Make it more parallel and make each mentoring step more efficient.
So, make it a system, not about the person. This is something that I have heard growing up in the technology. Don't make it about a person, make it about a system. So some of the system characteristics that we looked at for building Kubernetes mentoring programs, I'm about to take you through right now. And it's very similar to what you would do with a system when the system has a problem. You gather requirements, you identify the issues, things like that. You make it an engineering problem, not, a community manager problem, if you will. So the first one, of course, is don't build for what you think you need, right? In this case, the traditional one-on-one approach, right? You fill out a form, you get matched with someone, the end, or in the Josh example of the 4 maintainers, or one of the 4 maintainers grows with you. So most folks are actually launching mentoring programs without really thinking about the how and the who. And in this case, the personas of the contributors that you have in the program. So for instance, do you have doc contributors? Do you have Golang contributors? Do you have juniors? Do you have vets in open source? All of them have and need some kind of different mentoring to get either to the next level or just in general for what they're doing in life. So are you really listening to what they need? Are you asking? And have you really asked why they need a mentor? When I first came on board in Kubernetes, I asked a lot of folks this question. I was hearing this a lot. Oh, I need a mentor. I need a mentor. And come to find out, a lot of that was because some of the onboarding programs that we have weren't documented in the contributor guide. And the developer guide wasn't necessarily wonderful in order to get ramped up with, installs and things like that. So tackling that was actually a big undertaking for us as part of the mentorship program. In a previous slide, Josh actually showed you the mentor blocker survey, and he said that the second largest was not knowing enough. And this, again, is an issue with a lot of mentoring programs where you're bottling up the mentors at the highest level. And when you have, junior folks that can actually help other junior folks, for instance. So engaging everyone here is actually a key thing and a key system characteristic. We have to learn together, and really helps with building a culture that's okay to ask questions in public because everybody's asking questions and everybody's answering questions. One of the programs that we've created that really embodies this engage everyone tactic is our monthly YouTube series called Meet Our Contributors. This is a DIY screenshot of one of the very first ones that we did, and we just five contributors just kind of hopped on a Zoom call. George in the middle there live streamed it for us on YouTube, and we had people just asking us questions from kind of every medium. And this has really helped us because you can think of it sort of as like an office hours, a mentors on demand, if you will. And we've had a lot of fun answering a lot of questions. For instance, they go from how did you get involved in Kubernetes? What SIG do I join? Why are my tests flaking? Can you review my PR? How do I become a better code reviewer? All of those we've answered live, and they're all recorded, and we're attempting to index them now. We've done 30 episodes so far, and this is one of our most recent. You can see we're a little less DIY at this point, but you can see like the questions that are floating from Slack, and people on the line kind of helping you and walk you through that. Compared to one-on-one, we would have needed 500 more mentors, so throwing out some math for the people that we have helped out through this program, and we've only had 40 mentors on. So 40 people, we've helped out thousands. One of our code base walkthroughs that we did on Meet Our Contributors actually has over 3,000 views on YouTube right now. So that's really helping people out at scale. It's getting people onboarded, it's getting questions asked in a rapid way, and it really helps out that culture of I don't want to ask a low-level question, if you will. So, number 3, obviously clear goals, right? This is something that Josh talked about in the beginning with, what is the issue with one-on-one, and a lot of the time that is the fact that there's no clear goals associated with it. And honestly, this seems to be a desire for everyone, right? Not necessarily in open source, but I'm sure everybody here wants clear goals at your job. You want clear goals as to what it means to be, a senior engineer when you're a mid-level engineer. This is a kind of across-the-board thing. But not having clear goals with defined ends is really what a lot of a stump is in mentoring programs. We really don't have any time for ambiguity. And in Kubernetes, one of the very first things for us to get clear goals was establishing that contributor ladder that we showed you in the beginning. The contributor ladder is actually, we think, your first kind of P0 into establishing mentor programs. Why? Because it defines what the roles are. They clearly have steps on how to get there. And remember, those steps are more like trust steps. So when we say things like 20 code reviews to be a code reviewer, for instance, it is a little bit of an arbitrary number, but it's 20 because we're saying, okay, on your way to that 20, you'll probably have open dialogue from us, and we'll probably already know, because if you're at 20 code reviews, you're probably in our face. And we see you every day, right? Again, that building of the trust and building programs around that trust. So one of the programs that we actually are in development right now with having clear goals in a scalable way is group mentoring. And what we mean by group mentoring is taking groups of people. So in our case, we take 10. And 10 of these people are all on the same level right now. So again, going back to this contributor ladder, so you have 10 members, and they're all in SIG API machinery. And in Kubernetes, SIG means special interest group. That's who owns the code for again, like the API. 10 people, all members in API machinery, and they all want, and we need more reviewers in API machinery. So we'll take 3 mentors, so 3 maintainers, to their 10, put them in a private Slack room, have weekly Slack stand-ups, and then it becomes more of a peer mentoring activity than it actually becomes a one-on-one mentoring activity. And in that space, you're getting a lot of camaraderie, you're building each other up together, and you're learning together, and you're going on a learning journey together, right? And then the most important part of this is that there is a sort of a time-bounded thing to it. So according to our contributor ladder, in order to get to, say, reviewer or approver, you have to be with a project. We've spelled it out. I think it's like 3 months. And so in this case of group mentoring, you have 3 months with 10 people to make it to reviewer. That's pretty clear guidelines. And while you do that, you're getting coached and doing stand-ups from maintainers who are doing the job now. So if one-on-one, though, still sounds better for you, there is a way to still get clear goals with one-on-one at a scalable pace, right? One of those ways that we found is called the one-on-one hour. What this means is there are certain tasks that you still need on a one-on-one basis, right? You're like, okay, Paris, we can do all the AMAs we want, but I still need a human, right? That human in this case, I'm sorry, mentor. In this case, the mentor has 5 things that they can do with you, because those 5 things have clear goals. So they can pair program with you, they can do an AMA, they can do a code review session, and we figured out all 5 of those things, listening activities, and from what the project needs. So we've determined those activities and we've said, okay, you have one mentor, one mentee, 1 hour. And then we'll match folks based on that information, right? So again, there's no ambiguous end. You have clear goals, clear time frame, et cetera. And if there is something natural that sparks between the relationship, if somebody says, oh, hey, no, you could, I could definitely see you being a maintainer here, let's do something more regular, then it'll spark naturally, and it's not, being forced to be matched with someone for X time period. So you can see from just the examples that I've provided so far that multiple approaches is actually the way to go. That was one of our system characteristics. People have different learning styles. There's different strokes for different folks. I'm sure everybody in here learns differently. I know I like being in a classroom setting, for instance. It makes me accountable. I'm not surfing on Twitter. And other people, though, especially open source maintainers, love contributor guides. They like to read, just give me a checklist. Other people like to watch videos. Dr. Anita Sharma at Oregon State University really opened my eyes to this because she's working on a lot of open source research right now, especially with underrepresented folks, and making the ties there that maybe we're not being inclusive because we only have our contributor guide written verbally buried in the root of a community folder. So we've taken that approach and built programs around those different personas and different approaches, different learning styles, and even different locations. We've realized that we're in person sometimes during these big 12,000 KubeCon conferences. Why can't we do in-person things there, similar to like OpenStack's Upstream Institute? Things that fill those voids that we wouldn't necessarily have thought about before. So here's sort of our different approaches. We have remote approaches, we have in-person approaches, we have video instructional approaches, we have interpersonal approaches, all of which we've just talked about. And then, of course, we have stuff that's documented, which really brings me to the next point. Is it repeatable? We have, as community managers, we say, okay, well, we're running this program, or, oh, I'm coordinating this program. But are you the only one that's coordinating that program? How is that going to be sustainable? Is it documented? Can others do it without you? That's really the key thing here.
Oh, wait, I don't need that. I need the other thing. Thank you. So, given that, let's talk about succession. Not just succession and mentorship, but project succession in general. How many people here work on an open source project that has a succession problem or a potential succession problem? That you have like important things that have a bus factor of 1? How many people don't know that they're on an open source project that has a succession problem? This is a problem throughout the world of open source in general. People have written huge polemics about it, and it's a very common thing. And we ran into this in Kubernetes early on. So from the early days of Kubernetes, from the 1.0 release, we had this terrific release team of people who packaged up all of the stuff, created the sample operating system packages, created the testable images, etc., ran through all of the release tests, everything else to actually get a version of Kubernetes out the door, starting with the 1.0 release. However, there was a problem with this, which is each one of these great people had their one thing that they did for the release, and no one else knew how to do that thing, and no one else had the security access to do that particular thing. And this is a real problem, not just for the project, but for them personally, right? Because if only you can build, say, the operating system packages for the release, then if you're on vacation, we can't do a release, which means either, as actually happened with one of the Kubernetes releases, we literally delayed a release because somebody was on vacation, or you can't go on vacation. And either way is pretty terrible. On top of which, it also has a compounding problem, which is, as the person who best knows how to do that particular step, you are also the only person with the knowledge on how to change or automate that step. But you never have any time to work on the automation because you're always doing the work. So it becomes a trap, and people burn out because of this, and projects get into trouble because of this. Again, we're at the time problem. So if you have a group of people, all of whom are essential for some task in your project, all of whom are working full-time on that individual task, and yet you need them to train other people in how to do that task, how do you do it? They don't have any free time. Well, one of the things that the world of open source doesn't do frequently enough is look at how other industries solve these problems. And it turns out that a lot of other industries have looked at how to solve these problems before, particularly union trades. The way that it works, if you're in a union trade, if you're a machinist or an electrician or a plumber or whatever, is that somebody goes through the training, they become officially an apprentice under the union, and then you're assigned to a master, and you will work for that master at a reduced rate of pay, doing the work that the master needs to be done, and in return, they will show you how to do the work. So from the perspective of the master, because keep in mind, we are not looking at optimize the apprentice's time. We're looking at optimizing the master's time because that is our constrained resource. And so with the apprentice doing the work that the master would have had to do anyway, that gives them more time to mentor. So what we did, and by we actually, I came along in the middle of this process. This was mainly done by started by Jace and Enoch. What is Enoch's real name? Anthony. Thank you, Anthony. So by Jace and Anthony to do this for the release team, because we'd had this critical fail and everybody realized that was a problem to be solved. So they started out by actually giving names to all of the roles that people were performing. These roles already existed, in fact, right? There were already people doing specific things. We just hadn't given a name and a title to it. So we gave a name and a title to all of these things and said, okay, this person's doing this person's building the docs, this person is in charge of testing, this person is in charge of making sure that it's possible to upgrade, and all of that. And so then once you have these roles, what you do is you have them just hammer out a quick description of the role. What is it I actually do, and like a sort of loose checklist of the things that I do. Something that takes an hour and a half to hammer out, right? Initially it's going to be very sketchy. Now, our role handbooks have at this point grown to multi-page documents with a lot of resources and that sort of thing, but it didn't start out that way, right? That's what you develop over time. And even 3 paragraphs, you'll find, is vastly more information than you had about what people were doing before. And what it does is it allows you to get started with something else, which is you add a system of apprentices. We call these shadows in some of the programs. There's another one where they're actually called, what are they called in release engineering? I don't know. Anyway, there are different names for these. But we call these shadows in the release team. And so we did a release where every role now had an assigned shadow. And the way that the shadow works is, you know, if I'm the lead for CI Signal, and one of the things you have to do in CI Signal is somebody has to, every morning and every evening, somebody has to look at our test grid and see where the new failures are and make sure that the people who are responsible for that code pay attention to it promptly. Well, that's a manpower-intensive task, and it is perfect for assigning to apprentices. And in that course, they get to understand the tests, you know, what tests are running and how those tests tend to fail. They get to meet all of the people in the project. They get to know who's responsive and who's not responsive and how to reach people in the various media, which are all important things. And they're doing work that otherwise the role lead would have had to do. So they are freeing up the role lead's time so that he or she can spend that time showing them how to do things correctly. This has been actually a tremendously successful program. Let me actually show you via one person how well this worked in terms of ratcheting people up the contributor ladder. So this was the 111 release where I was the release lead. And my CI signal person I recruited somebody from Google Quality Engineering, who's very talented, Aish. And Aish took on the role of CI signal. And in the next release, Aish went up to be the shadow for overall release lead. And, to learn how to manage all of the different parts, how to coordinate all of the different people. And that meant in the next release, she moved to being release lead herself. And in the meantime, I came back to do CI signal, because actually I hadn't done CI signal before. So not only this, it gives you a re-entrant. One of the other problems with a lack of defined succession is it means that people can't leave even temporarily, right? As in, if I'm a project leader and I need to take some time off, I don't want to do it because there is no way for me to come back. Whereas with this mechanism, I can always come back. I can always rejoin the release team whenever I feel like it. So this has been our most attractive program for recruiting new contributors. We're branching it out here, and it's because it is so comfortable for a new contributor because they know what they have to do, when they have to do it, and what will happen when they do it. So let me go over again in the terms of how to design a mentoring program, why this is successful, right? So in this case, mentorship is not a separate activity. It is part of the process of producing the release. It requires no extra time for mentors, or minimal extra time. It's structured with goals, tasks, and graduation. We have a defined time limit, which is a single release cycle, and the constant repetition and cycling means that documentation gets constantly improved, processes get constantly improved, so that the whole process gets better as we go.
And from that inspiration, from this great program that Jace, Josh, Anthony, and so many other people built, we've been inspired to build this elsewhere in the project now. So, for instance, contributor summits. We have a face-to-face team that builds contributor summits at KubeCon. They all have roles, just like here at SCaLE. For instance, registration, people that are doing the content, CFPs, they all have role books. And then another engineering example is our API review committee. API being probably the most complex thing about Kubernetes. It's kind of the heart, with Node being obviously like the kernel. But the API is very complex, and new contributors a lot of the times want to go immediately to that or to Kubernetes. And the API review committee takes shadows now of not necessarily new contributors, but contributors who have been around a while looking to, again, have mentorship for themselves as well, and gives them that purview into how to review an API for breaking changes, and that helps out the API reviewers too, because they don't have to do any, extra training and things like that, because the shadows are there helping, doing documentation, asking the why questions and things like that. So there's all different ways that you can approach shadowing and apprenticeship and things like that for your projects. Be creative. I think that's the most important part. And also, again, ask questions, especially to yourself. There's things that I asked for my community management role, where I said, how can I take this task and make it a team, and really scale that way. So to review some of the system characteristics: build for personas, engage everyone, have clear goals, multiple approaches, repeatable, because we want you to adopt this. Mentorship is, again, very traditional thought process of, and we think that it doesn't have to be this way. So we've created a lot of documentation around the programs themselves, the processes, and it's important for you to know that you don't need to be a maintainer to build these programs for any open source project that you're involved with. When I first got involved with Kubernetes, I was not a maintainer yet. Obviously, I grew up to one, but this is really letting all of you know that you are empowered to do this as well, and this will actually really help the maintainers too if they see other people that are building programs for them to get help where their time isn't, being stretched thin. That's really the key kind of takeaway here is building programs that make sense. That have those things like time in play and in consideration. And really, you should build a mentoring program today. Thanks for coming. Any questions?
Yep. So, questions?
Give us a chance to think about what you said.
So, by the way, one of the other things I want to add is we showed you a whole lot of programs and everything. Keep in mind, all of this, this whole complexity of different mentoring programs, different approaches and stuff, this took us 3 years to build. So, don't try to bite it off all at once. Start with one thing, either the biggest pain point you have or the thing that's going to be the easiest to implement, and do that. Because not only will that allow you to make some progress right away, but also it'll build credibility that new approaches to mentorship are useful.
How much of the requirements do you put on the mentee versus the mentor? That tends to be what is, I don't want to say detrimental, but what most mentors feel on top of the time constraint is, I don't know what they want to learn. How do I know what they want to do? Or,
right.
I want to learn programming. Cool, what program? What language? Where do you want to go? What want to do DevOps?
And that's why we don't subscribe to programs like that. I mean, that's why I feel like it's subscribing to like the free-for-all, like come grab a mentor, ask for a mentor, like isn't scalable. Like right. So that's why we've said, here's the mentoring programs we have to the mentees, and you serve those, like that, because that's what we have and that's what's available. Because anytime you get into these situations like that, like, and that's where I said, and that's in the beginning too, when I was like, listen and find out what exactly it is they need, because I was hearing a lot of that too, especially when when I first started. It was, oh yeah, no, I want a mentor for Go. And then I'm like, okay, well, there's a ton of Go resources online. Like we are, this is an open source project. We can't necessarily teach you Go. We'll teach you how to contribute. We'll teach you the internals of Kubernetes. There's only so many things that we can do, and I think having that expectation drawn out for both mentees and mentors, and we do have like expectation documents. Again, more documentation. We have so much documentation, y'all. I swear, it's just like Kubernetes/community. Take all the documentation you already need.
And in terms of expectations, in terms of mentee versus mentor, like for the shadow program for the release team, we actually have exit interviews for both mentors and mentees. And we look for problems on both sides, because you have problems on both sides, right? You have mentees who just disappeared, but never officially dropped out of the program. I mean, these days we actually have several shadows for each position, partly because we have so many people wanting to participate, and second because we find that about half of them drop out before the release, because they just, no matter how much it's documented what the time commitment is, people don't necessarily understand what that means for their personal schedule. And then we also have mentors who are, end up being uncommunicative, end up not providing enough instruction, end up just not making use of their mentees. And so then we cycle for that, talk to people. Sometimes, I remember one case we ended up catapulting a mentee directly to a leadership position because her mentor went completely AWOL. She basically took over the position and improved it in the process. So we also provide an opportunity for people to shine. It's a two-way thing, right? The mentor is expected to do certain things, the mentee is expected to do certain things, and you need to look at both sides.
Where do your, and maybe you've already covered this, but where do your mentors go after they finish the mentoring program? Like, what is sort of the next step for them usually?
Putting themselves into an owner's file.
Yeah.
So like in the case of group mentoring, like, at the end of 3 months, Like, you know, we've had consistent feedback loops with you because, again, it's sort of like I don't want to say class. Ooh. I don't want to say class, it's not a class, right? But it sort of feels that way because you have a 3-month period to complete it, like you have 20 things to do. But anyway, at the end, your goal then is to PR yourself into an owner's file. And then you've made your pass or whatever, or your first PR.
Except that if you are an owner, we're going to touch on you to participate in mentoring programs pretty much forever. So, but it is one of the steps of getting from reviewer to owner is, hey, if you're a reviewer, we expect you to mentor some people because once you're an owner, we really expect you to recruit additional reviewers. So we have to know that you can do it. And
that's actually written in our contributor guide as well. Like under, I think it's like approver, one of the bullets is mentoring.
Yeah.
So it's just this consistent cycle, if you will. Back to you really quick, I just wanted to address something. That's why we started Meet Our Contributors. That was why. It's because I was getting these just like really random, like I need a mentor for this really random thing, and that's why it's just like we only have so much time, right? And like again, going back to expectations. So I was really curious, like let's just have office hours and see, like I'll say I'm a mentor, ask me a question. And I want to see what kinds of questions they were asking. And we had 2 or 3 sessions and realized that a lot of people were asking the same question. So how can we build what we need and what they need, you know, together? And that's kind of what the programs that we have now with like the shadow programs and group mentoring and things like that. And then also like including those things on our contributor guide was really helpful as well. So like in the case of Kubernetes being built with Go and people needing Go mentorship, we have like a page that says like here's where you can go for Go help. Instead of just leaving them hanging, for instance, or like, hey, go to, you know, this channel for Go help or something along those lines where it like closes that loop for them, so they're not coming to us with very ambiguous questions that like we necessarily can't solve that moment.
So any more questions?
It's like how well do you think these systems apply to just like large corporations not doing open source? So kind of leave off this.
So, I mean, I think that a lot of these could be used internally at companies. One of our previous times we gave this talk, one of the people who was attending specifically because her job was to revamp her corporate mentorship programs inside the company. Because the problems really aren't different, right? Your most knowledgeable people in the company are also the ones with the least free time. And getting them to mentor is hard because you're begging favors from them. And now, the problem you're up against in a company is that if you want to implement these things, you need buy-in. I mean, it's actually true in an open source project too, right? You need buy-in from the leadership. They don't necessarily have to do it, but they have to agree that it's worth doing. Because ultimately what needs to happen is you have to say, hey, if you're a distinguished engineer for our company, then it's expected you're going to spend 10% of your time on mentoring, right? That needs to go into people's job goals if it's going to happen. Because if people have to make a decision between the thing that they know is the right thing to do and the thing that their boss who approves their annual bonus wants them to do, the boss is going to win most of the time. Some of them are more appropriate than others, right? I mean, not very many companies are going to be up for an open meet our contributors approach, et cetera, even internally. I mean, some of them should, but, you know, interdepartmental rivalries and all those other things really become a problem for that. But things like apprenticeship programs, like I say, the apprenticeship programs came from industry, right? It's not originally an open source thing at all. And if you go into factories and other things, you'll find that is in fact how they train people. So it's completely applicable. And for that matter, things like the one-on-one hour would actually be a really good program for internal because, again, people's time is scarce, but you say, hey, we're going to put a meeting on Friday for you that's going to last 1 hour where you're going to mentor a junior engineer. And you could completely get management buy-in for that.
The group mentoring too actually came from, like many moons ago when I worked at Comcast, and trying to staff call centers and trying to scale up like 50 plus people, you know, into these tier 2, tier 3 kind of roles. We used group mentoring. Because there, you know, there always seemed to be like at least a few leaders in the group of 10 that weren't necessarily, you know, when I say leader, they weren't necessarily managers, but they were like just, you know, natural leaders who would come into these peer groups and just sort of peer mentor them because they wanted help as well. So that is sort of like what had my kind of like brain juices flowing when we built group mentoring, because it was like, how can we scale super fast in some of these areas where, you know, thousands of issues are coming through in a way that makes sense. And that's when I was thinking about call centers and staffing up call centers and doing it rapidly, and but still having like kind of quality and engagement from people in safe spaces. So that was the sort of inspo there.
Anything else? It's time for one more question, if anybody has one. Okay, well, thanks. We're around the conference. So you can find us if you think of a question later.
I want to clap for you.
Yes, thank you.
We don't stop talking.
I never stop talking.
I don't either.
check, check. Handheld mic check. Check level. Check, check. Lav check. Check level.
See what I mean about that? So it's fairly far out away because it's bent away from your face.
Okay.
If you have it on the other ear, it'll bend in, or you can
Okay.
grab it and bend it back.
Okay. So I just let this thing hang?
Yeah, exactly. Yeah.
Okay.
You clip that, drop it in the pocket, clip it to your belt, whatever works. All right?
Yeah.
All right, you good to go?
Thank you.
You have a good day. Good luck.
Right. Welcome everybody. My name is Chonan. I'm the CTO at Camino Financial. First of all, thank you for coming to this wonderful event. I've been coming here for the last, 5-6 years. And I'm really surprised at the turnout today. I was initially thinking there was nobody going to be coming to my talk, because I remember going to Hong Kong in 2003 when there was SARS, and literally there's more people here than the empty streets of Hong Kong. So thank you. So let's get started. Before I jump into the topic of crafting a life-changing tech internship experience, I want to tell you a little bit about myself. So I'm the CTO at Camino Financial. I have about 20 years of industry experience. My verticals obviously been in fintech, but also have been exposed to digital media and influencer marketing. Earlier in my career, I've been very focused on working at Fortune 500 companies. More recently, last 7 or 8 years, I've been working at startups here in LA and also in Beijing. The company where I work is called Camino Financial. Camino Financial is a data-driven fintech platform that pioneer offering business loans to the Latinx market. So that's kind of the background, and let's jump right in. So I want to ask everybody, think about it for a moment. What's the one moment in your life that had the biggest impact, on your career? And this is obviously different for everybody, right? For instance, if you were a celebrity singer, maybe it was this audition experience that you had, when you were in grad school, right? Maybe for actors and actresses, maybe these up close and personal, thing they had when they were a kid with this particular actor or actresses. As for me, I think I would be, lying if I was to say, I've always wanted to be a CTO, and because of all this one experience that I had in the past. But I did have a really, really pivotal experience in my life, and that was this internship that I had in the summer of 1999. It was a tech internship in Tokyo, Japan. And a little bit more context, I met the CEO of this Japanese company, actually in New York, where I was going to school. But he was very kind, and he asked me if I was interested in the internship, and I right away, signed up for it. So, there I was in 1999, at 20 years old, showed up in Tokyo, and I had this, 3 months of, fun and learning and all kinds of stuff. And I will show you a couple of pictures of my experience there. But first of all, let's talk about the company. The company is called Digital Garage. The company actually still exists today. They are listed on the public stock exchange in Japan. And back in the days, I think they were the first ISPs in Japan, and they've had a lot of different e-commerce / online business underneath the company. So I was very fortunate to work on a few of these projects, and this was, back in the days, this was almost pre-Google days, so there was InfoSeek and Yahoo and all kinds of wonderful search engine technology. So one of them was InfoSeek, and it was a localized version of that, and I worked on it. And I worked on WebNation, which was an e-commerce shopping site. And then I also worked on another project called SonicNet Japan, which was a online magazine for rock music. So they were a wonderful project. And the two gentlemen that you see are, the co-founders of the company. On the left, that's the CEO, Hayashi-san, who I met in New York, and was kind enough to extend an invitation to his office to be an intern. And to the right his name is Joey Ito, was formerly a MIT media director at the Media Lab. who recently stepped down last year due to a scandal, but he's still with the company. And these were, my coworkers back in the days, and this was Tokyo, and on the left, that was the creative team who I spent a lot of time with. And this was back in the day when there was no CSS or JavaScript. So if you want a website to look beautiful, you need to mock up your images. And the creative team was doing that. Look how young I was. I was like, my coworkers, were showing me streets of Tokyo, and there, the CEO again, making funny faces. But it was a really fun environment, a mix of local Japanese engineers and also engineers from America. And I got to party a lot, I have to say. I went to a festival called the Fuji Rock Festival, and these was, I was doing a live coverage of the event there. So I had the backstage pass, and I managed to, meet some of these artists, like Rage Against the Machine, Limp Bizkit. I mean, these were all, classic rock bands in the 90s and whatnot, and it was pretty cool back then. And I was out there for 4 days, 3 nights, just doing a lot of tech support on the spot. That was cool, and I also got to travel a lot in Japan, went to Kyushu and saw the ocean and met wonderful Japanese families, more partying, and hanging out with teenagers, and cosplayers on the streets of Tokyo. So very, 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 very fun. But it's not all fun and no work. So I did spend a lot of time, learning. This was my first exposure to open source technology at that internship. I learned Python, I learned Perl, Zope, which was a web application framework, VI Bash and PostgreSQL. And a lot of these technology, actually, I would say all of them are still around today, which goes to show the strength of open source technology. So why am I saying all this, right? So in hindsight, I was very, very, moved by the experience. I learned so much and had so much fun. And along the way in my career, there were always moments that I thought about that particular experience, and that always had some kind of impact and influence on my decision in my career. And so I always thought, okay, maybe there is some way, maybe I can offer it someday. And that opportunity presented itself 3 or 4 years ago when I joined Camino Financial. So back in the day when I first joined, I was employee number 4 or 5. We were very small. And today the company is about 70 people with 2 offices, one here and one in Mexico City. We're a lot bigger now, but back in the day we were bootstrapping. We didn't have a lot of resources. We didn't have engineers. I was the first engineering hire. So obviously I was very busy coding during the day, working alongside the CEO and a few other people, founders of the company. But in the evenings, right, I would end up at a lot of the startups here, actually meetups in Los Angeles. I would just go and try to meet people, learn new things. And I remember one particular incident. Sometimes you go to meetups, and then you happen to see the same guy over and over again. So there was this guy, his name was Peter, and so I saw him a few times, and finally I decided to, introduce myself and strike up a conversation. And say, hi, I see you a lot of time, and what do you do? And then Peter told me, so actually I'm an Uber driver. I drive Uber all during the day, but at night, I take Coursera classes. I do a lot of coding, and he was trying to show me his project, and that was really cool, right? But the very same week that I met Peter, I was hanging out with some of my friends who I think was the CTO at one of these startups on the west side, a very well-funded, startup in LA, tech companies. And we were just having lunch, and my friend was telling me, hey, Cho, I just lost another engineer last week. and it's so hard to replace. You know, I'm gonna have to spend a lot of time, you know, trying to get a new hire in place. So it dawned on me right at that moment, like, hey, look, we have this really great ecosystem, you know, in LA. Got a lot of young people, very hungry, wants to learn, right? And then we've got a ton of well-funded tech companies, but there is no bridge to help people that wants to work to end up in some of these companies. So I decided maybe, I guess I, as the CTO of the company, could do something about it, you know? So what I did was I started, you know, designing this internship program. And just to make sure that we're on the same page, the internship program that I've designed is, you know, not so much the 3-month summer internship programs that you guys see a lot that typically tech companies do. The one that I've designed is more for people, they're currently doing something else, not in software, but they want a career switch, but they don't have a way of doing that. So I kind of, you know, sat down and thought about that, and the first thing I was doing was, you know, what would be the ideal profile, right, of our interns? And in the beginning, I was very stubborn about some of these requirements. I was thinking, hey, you know, the intern has to have, you know, this kind of background, computer science, what kind of exposure and all that stuff. But at the end, the lessons learned was that, hey, I want to look for a good problem solver. You know, it doesn't matter if he has this many tech experience. In fact, if they have too much tech experience, they probably are good enough for full-time somewhere else already, right? So, but too little isn't good either. So there has to be some kind of balance. I remember this one particular conversation that I had with one of my initial intern hires. You know, he showed up at our company, and we had this interview. So tell me about yourself, your experience. And then he was saying, oh, I worked at McDonald's and at a couple of fast food restaurants. And then when I heard that, my heart sank. You know, I was like, this couldn't possibly be a good fit, right? Then he went on to say, in fact, these restaurants are owned by my parents, and in my spare time in between shifts, you know, I would be doing some coding, and I wrote some code to help manage the timesheets and people, and then that's when my ears perked up and stood up, and that really piqued my interest. And he said, can I show you the code? And I reviewed the code, and it was really, really good. Of course, it was missing a few things here and there for production quality, but the gist and the potential were obvious to me. So going to, with that lessons learned, I became very flexible about the type of people coming in, and not so stubborn about some of these things. So no experience is okay, no CS background is okay, right? And no bad credit is okay. So, so these are, but in order to filter, these people, I have to come up with some ways so that it's efficient for me, right? So recruiting, how do we find them? So a lot of times, I often think of myself as Professor X. I have this telekinetic ability. When I see somebody, maybe I get a sense of that person's skill set. Just kidding. But there is obviously there has to be some kind of methods in place so that this is scalable, right? You can't have, you're growing a team. So, of course, like we would post our internship ads on Indeed and whatnot, all kinds of recruiting forums. But then we will have take-home tests. We have phone screenings. We have online tests people can take, so that I can really filter down, the funnel, and try to get to the intern that probably would be the best fit for the company in the most efficient ways. And after filtering them, we have the interns meet everybody in the company, and then we kind of do this American Idol style voting just to see, just get a sense of fit and if they should be joining the internship program. So what exactly do they do in the internship program, you may ask? So a lot of things, they're often kept very busy. There is 3 major components to it. There's a theory piece, right? And then there's a practical piece, and then there's a final presentation at the end of internship. The theory piece is all about, doing their readings at home. I give them reading assignments, usually books, that's great for computer science, software career. One of my favorite books is Pragmatic Programmer, so that's usually the first reading assignment. And then I give them midterms. Usually I will have them pick out certain, core pillars of computer science and have them study that for a period of time and then give them midterms. So it could be database, could be operating systems, right? People that are just missing in some of these fundamentals and then trying to get them really good at it. Then we have the practical piece, which basically I assign them work, which are similar to what our typical full-time engineer would do in the office. They have to, participate in our sprints, and they get assigned tasks. But obviously in the beginning they will get the easier ones, right? But at the end, they will get to do the hard stuff. So that's the practical piece. And then at the end of the internship, which could be usually 6 months to a year long, they would do this final presentation and talk to the whole company about what they've achieved here. Usually they pick a topic of their interest. Maybe it's something they've done, maybe it's something they was really curious about, and they spent like a good month just writing up some code, right? Putting together a demo and presentation, and they would do the presentation, and then they would just present to the whole company. And then aside from all that, I do stuff like getting them out to conferences like this, come and learn from peers that are in software. And so last year we actually came to SCaLE as a team, and that was actually a lot of fun. And then sometimes we go to the AWS training events. And then the other thing that we kind of do a lot as well is to visit other tech companies in LA. Some of my friends that are CTO somewhere else, and we just have like an open house for an afternoon, and we just go and chat and learn from each other. So that's kind of the gist of the internship program. But the meat of the internship program actually is the mentorship itself. This is something that I do with everybody that comes through. Usually I spend maybe an hour, half an hour, every 2 weeks, just kind of, talk about my, stories and battle scars, right, and things that I've seen. And usually it's like, production deployment failure, or faulty logic in implementation, or corrupted databases, all these battle scars, right? And I try to share my wisdom as much as I could with these interns so that they could learn from it. And it's been a lot of fun, and I think a lot of the mentees that came through in the internship, like, they just learn all these, wonderful, lessons. And then the next thing is to think about when you're running these sort of internship program is what sort of challenges, right, can you expect from running such an internship program. So there's a few things to think about. Sometimes is, people could get started, right, and then they might quit halfway, and that's usually I would say the biggest challenge, because it's a very rigorous program. People, they get hit in all directions. Typically in our startup environment, there's often a lot of work, and obviously they also have to catch up on some of these other assignments that I give them, reading assignments or take home, whatnot, or midterms they got to prepare. and obviously, it's a paid internship, so it's good for some of them, but sometimes things happen and they just don't have enough money, so money, another thing, it could be a factor for some of these people to think about, like, whether they want to stay on for this long, right? Or they just need to go out and find a real job that pays. And then pressure, obviously there's a ton of pressure within the company to deliver, because in the beginning, especially with such a small team, everybody gets to see. Duration of the internship is also vital. You could, sometimes people just are not sure, if they can commit something like 6 months to a year, right, for a career switch. So if you make your internship too long, people are just like, all right, I've learned enough, maybe I go somewhere else after this, or what have you. There's a lot of different complications behind it. Too short, they might not have enough background or foundation to really do well in the job. But I always tell them, in many ways, this is a lot better than a boot camp, because the boot camp setups in LA, or typically in different places, are more on the theory side. They don't really always get to apply what they've learned in a real environment or setting. So, that's why I tell people, you just gotta get through it. And then, of course, the time commitment. This is another thing. Sometimes people have trouble just committing that much time, and then, with all that pressure, they could give up halfway, right? And then at the end, it's a waste of time for everybody. And then recruiting is one of those things that could take up a lot of time. So initially, with us at Camino Financial, I was doing all the recruiting myself, so it was taking up a lot of time. Now we're better. Now we have an HR person, and so I have help. But this was one of those things that took a ton of time. But at the end of the day, though, I think the philosophy really works. Like, given if you get these things, challenges, in a place where it's good fit for your company, the people that are in it, like the interns that are in the program, they do go through a very interesting time in their life, because they will obviously have fun, right, with their peers, but they will also get these pressures, and sort of the philosophy behind the program is, you give them this pressure and then this real world challenges, and that will show and reveal the true potential from the experience. So that's pretty much, the kind of the idea behind it. I want to show you some highlights from the program. Another a slideshow. those were the highlights from the program, and I've been running it for the last I would say 3 years or so, with some success. I would say 90% of my engineering team have full-time staff that are picked from the internship program. So, and one of the most interesting things is, at these every time when somebody finishes graduates from the internship program, I usually have a concluding session with the interns, and I remember this particular one that was very interesting. The intern came in, and then we sat down, and I asked him, "So what have you learned from the internship program?" And then he started going like, "Oh, I learned algorithm, data structures, how to code, and stuff like that." And I interrupted him. No. I mean, what have you really learned, from the internship program? So he paused, thought about it for a long time, and then he said, people have issues, projects can get hard. Personally, I've got a ton of things going on myself, but I'm glad I did it. I learned so much, about life, and for me, that was a very, a grateful moment for myself, and I feel a great sense of just accomplishment, and so, it just goes to show and confirms that there are talents here in LA, and you just need to make sure you develop them, and you need to spend the time, commit the time to make sure that they go through the rigors of effective and comprehensive internship program. That's the end of my talk. Open to questions if you have. Yes.
Sure. I'm very much beginner with it, and I've been taking a tutorial online about JavaScript, and I'm wondering if you could talk to us about a little bit about the languages that are used for coding right now, because I don't want to be chasing the wrong rabbit.
Sure. So the question is, the gentleman at the back is learning JavaScript, and he wants to know about different languages that's out there, right?
Yeah.
So there are so many languages. There's always paradigms and trends, but JavaScript is a popular programming language to learn. I think it's very suitable in the sense that it could be applicable for front-end development. It could also be applied towards back-end development. The language of our company is Python. We do a lot of Python programming. That's kind of my language. And then the reason I picked it is because it's easy to pick up. Even for somebody like you, if you have never been exposed to programming, that is one programming language that's that's beautifully designed and easy to learn. There are obviously other programming languages like, Go or C++. I mean, the list just kind of goes on. And each of them have their own pros and cons. It really kind of depends on, what's the goal, right, for your learning. Are you just kind of casually learning about a particular programming language to just get your hands dirty?
As you can see, I have physical mobility issues.
Sure.
And I need to bring my income up more. And to be honest with you here, I need to be in touch with more people than I do right now.
Absolutely. And I think there are some really good startups around Pasadena. Meetups around Pasadena that maybe I think some of them, they do introductions to certain programming languages. I think those would be good to check out as well.
I'm visiting downtown. I live in near the Air Force Base up north.
Oh wow, okay.
I'm in the other desert development.
Right. Yeah. So if you want to, maybe we can exchange contact. there are some online forums that, you know, I'm happy to introduce to you, and then you can maybe connect with more people over there. Yeah. Yes.
So obviously having some tech skills is important.
Yep.
But the other half that we don't teach in college a lot of times are the soft skills.
Correct.
So what kinds of things would you want to see from my students in terms of soft skills?
I think in terms of soft skills, that's what I realized over the years. Sometimes good engineers, they're not exactly sociable. So almost most interns that come through, they have, you know, I mean, sometimes, you know, it takes a bit more effort to get through to them. But I think what's important is to foster a culture of communication, you know, with the interns and help them develop some of these soft skills. I think, you know, in our company, we've done stuff like brown bag lunches, and in a nutshell, that's like getting people up on stage, usually on a Friday afternoon, you know, over lunch, and they pick a topic of their interest, and they talk about it for like 20 minutes, and they interact with the crowd. So that's one of the things that we do to help kind of develop, you know, their soft skills, and obviously putting them in a team situation. That is another way of developing, you know, because you cannot work in a team if you don't communicate, and you know, and then there are obviously like nuances, you know, and that's about how to go about getting these skills, and I would cover them usually in my mentorship session, you know, maybe like just elaborating a little bit on, you know, what's the best way to approach certain topic, like should it be a wide open discussion with everybody on Slack, right, or should it be a real meeting with a couple people, you know, and then maybe even explaining the dynamics, you know, of, say, in a meeting when there's an executive in a room, like how do you say, or you know, certain things so it doesn't, you know, cause, you know, problems down the road. So, you know, these are like the different ways that we do to help cultivate that soft skill. And in our company, I feel like as we do these programs over the years, like you know, communication skills has been one of the key criteria in our hiring and recruiting process. So now more often than not, if somebody have trouble, that comes through an interview and have trouble sort of explaining themselves, I'm working in the business environment, so I need to make sure whatever we do, right, also makes sense for the business. So we need to definitely, you know, have some kind of, you know, filtering and selection criteria in place, so to ensure success of the program, basically. Yeah. Yes.
First of all, I really like the presentation.
Thank you very much.
And I wanted to ask you about what are some challenges that you face in administrating?
Sure. I've had a couple of different challenges in the past. Usually is not, I would say, sometimes it's the frustration which I have to manage, right? Because usually in a startup environment, we're going 200 miles per hour, you know, with this fast-moving train. And then all of a sudden, like, you onboard this intern who may or may not be experienced, or maybe maybe the person's experience is, you know, is very, you know, spread. So it's very hard to right away, you know, apply somebody's skills to our, to our office, to our company, or our business problem. So I need to manage their expectation, because most of these interns come in, they want to prove themselves, they want to do so much, right? And I'm happy to let them do it, but I gotta feed them sort of piecemeal fashion. You kind of start here, and then you kind of, progress towards something that's harder or more challenging. And then at the end, when they could take on a challenge without me holding their hands, that's when I can step back and just enjoy the fruit of the labor. So managing that expectation and that frustration on both sides, I think that's usually a big challenge, because people, some people that come in and say, I got the skill set. I used to do this for my, family business. But then if you look closer, that code is missing unit tests. That code, is not production grade. And then they have to understand, how to do Git properly in a team environment, and they have to go through pull requests, which a lot of times when interns coming in, they don't have that kind of prior experience unless they've worked in, bigger companies or, or some kind of team setting. So making sure that person can be ramped up is a lot of work, and we have to do it obviously efficiently. Now it's a lot better because we have a much bigger team now, and so I have people, that helps me, right, to get some of these people onboarded, and then I just focus on the mentoring. So stuff like that, that helps. Yeah, other than that, it's just kind of like, making sure that, the interns just kind of, sometimes I got to put myself in the intern's shoes and make sure that they don't quit halfway. That's a thing that I typically don't like, because, what I'm doing is a very tailored program. It's completely personalized. I come in, I work with somebody, and I look at how they're doing, right, and then I assign the midterms, depending on their interests and skill set. And the timing is also flexible, right? So I try to work with them as much as I could. But there would be times when people just can't take it, and just sort of like pacing, that's something that's very important. The hardest thing is sometimes I have to let people go too, like people just don't, don't ramp up, but as a business, I will have to do that. But maybe next time, if I were to do this in a non-profit setting, maybe it's different. Like I could do a lot more in terms of hand-holding and ramping up. So these are the challenges, basically, I gotta figure out. Yes?
What recommendations would you give to somebody who's like just entering the field with like very little experience? Like, do you recommend like learning how to like code like online, like through like the boot camps, or like what, like going to the meetups?
Yeah. So there are many ways to approach it. There's no one quick or fast way. I think at the end of the day, building up your confidence is actually very important. There's things you can learn online, and of course, like when you get into one of these internship programs, the company will train you too. There are programs everywhere, but sort of building up the confidence, getting some of your basics so that you could getting your basics right, so that you could like present yourself, when you're having these interviews with the company, because that's the fastest way to learn. You could sit at home all day and just do your own thing and learn yourself through online courses. That's fine, but at some point, you're going to hit ceiling very fast because you're not getting feedback, right? Very few online programs have feedback. The kind of feedback we do is like, as you can see from the program highlight, you sit together with a full-time intern. They're telling you, oh, this should be done better, and then we do pull request reviews, just like in open source community, but we do it within the company setting. People are critiquing, your source code line by line almost, you know, that's where you learn the fastest, because you're going to get feedback and you feel a little bit pressure. And this happens all the time. Like, usually my interns come in, the first pull request, I tear their code apart, because it's just like, this, you know, all these crappy conventions got to go, or this is bad logic, you know, this is going to get into memory issues. You know, that's not something you can learn online or by yourself. It's harder. So if you have the basic skills, then you can try to, you know, be comfortable with applying to some of these internships. And even the act of applying, right, is very helpful, because you go through these, you know, testing, interview stages, you know, you get to do all these online things. But the most important thing is when you go and meet their hiring manager, right, you're going to say, hey, you know, this is the amount of time that I've spent, you know, studying this. I'm new, but I've, you know, invested time. This is my code, right? This is the project I've done. If you could show all that, you know, basically people see that you have potential, right? And then that's kind of like, you know, how you can get your foot into the door. So just to kind of summarize, right? Simple project, you know, demo, website, GitHub, repo of your work, and then of course doing some of the online courses to at least know the basics, right? And then with that, you know, keep trying to apply for internships. You know, another way of doing it is also go to coding boot camps. They also sometimes help you out, but the challenge is you got to pay for coding boot camp. But internship, like ours, is a paid program, so you do get money. And of course, it's not a ton of money, but you do get paid. You can afford a place to live and things to eat. But that's kind of your stepping stone, and then from there you get into the industry. Yeah. Yes.
Kind of building on that question a little bit.
Yep.
Is I'm also a student, and I'm pretty much learning every language that I can get my hands on a little bit, learning most of the fundamentals and stuff like that.
Yep.
Would you say that's better to do as you're starting off, or would it be better to maybe take one language and run with it and try to be like a master of one versus a jack of all kinds, you know?
Yeah, I definitely recommend picking one to go into, just because at the end of the day, I think, depending on the company, some companies, they like sort of an all-rounder, but the thing is, most companies, there's always a primary language they use, right? Very few, unless you're like Microsoft or Facebook, I mean, they have like all kinds of languages because they're so big. But if you're talking about these, you know, LA companies that are like sort of mid or small size, they can't afford to have a tech stack that is split in like 5 different languages. But if you're good in one particular language, right? For instance, like, you know, Node.js is a very popular one for LA, or generally in the tech ecosystem around the world. So if you're really good at that, obviously your chance of finding a job or internship is a lot higher because people will pick that. But on the other side of things, some other companies, like, they're language agnostic too when it comes to hiring. They just want to know that you can code and figure out logic. So even if your experience was in another language, you know, then it's they're just going to assume, you know, that learning is transferable to the new thing. So if I were a hiring manager and I look at a resume, you know, you got 10 languages and your experience are like just coding bootcamp or no experience, then for me, you know, it doesn't look very enticing because it means you've dabbled on in a lot of different things, but you're not very focused in one. But say if you're very good in Java, for instance, and then you got a repo full of Java projects, and you religiously commit your code, you know, almost every week, that says something about you. You know, and that says that you are somebody who is very good in Java, right, and very hands-on, and And I think that goes a lot further. Because what's going to happen is, if you write so many things on your resume or CV, you go into an interview session, they're going to start asking you questions about these languages. And every language is so complex, there's all these little things. There's no way you can pick up everything. Not even me. I have 20 years experience, and I can only say, okay, I'm probably most, fluent in Python. But like a lot of stuff like Java that I've done before, but because I don't use it that much anymore now, there's all these new versions coming out and it's got new features. I have no clue. So it's important to keep yourself up to date, with one, maybe two. If you want to do one front and one back end, then maybe two. But that is something I would recommend. And then alongside of that, usually you should be handy with Git or some kind of repository tool, because it's now sort of the minimum requirement. Like not knowing how to do version control is it's not good in the field. Yeah. Anybody? Yes.
Outside of internships, have you ever done anything like company tours where you brought in students and just to kind of show them what the company's about, what it's like, what you're looking for, just to give them some expectations?
Yeah.
So when they are ready for an internship?
So I have not done that, but I've done the reverse, which is I've gone to schools. I've gone to Caltech. I've been there already a few times this year, and I participate on in their career fairs. And I would take my interns with me, and I have them like explain the program and what we're looking for, and also tell them a bit about the company. So that's been very effective. I like the idea that you brought up, bringing students in. Maybe this year that's something I'll try, just to see if I can get a group going. I would love to bring in even high school students, college students, just to get them acquainted with our program. We've had a lot of success too last year with our summer program. These kids they just like came in, even though it's 3 months. They learn really fast, and in fact, some of the code they wrote today still sits in production and making money for the company. But one thing I need to clarify is, I think for summer internships, we're more particular about the person's experience, their academic background. Like usually I would look for people with CS background, but the sort of the year-long program, the career switching program, then I'm more open to, whatever background, as long as you kind of show some potential. So that's kind of my experience so far.
I just had a student who took a company tour of ZipRecruiter, and
Yeah.
he was just flabbergasted about how much he learned just by taking a tour.
Yeah, usually it's a fun. So I don't know if you recall, during the slideshow, we've sent interns to other tech companies, and usually these are bigger tech companies like Google, Verizon, and they usually see a lot more. And I like doing that because it kind of gives them sort of a guiding vision on where we want to be, when we're bigger. So now I guess in some ways we're a little bit bigger now. We could start having people over and just see how we're set up and all that. Anybody else? All right, I guess that's it. Thank you all for coming. Thank you.
All right, we'll get rolling. You're all here for consensus building. This is what you expected. You know, here for some free SV talk or something like that. Okay, good. All right, cool. All right, so my name's Richard Waring. I'm a production engineer at Facebook, and I've been, I guess, you know, working on some relatively large projects through my career at Facebook, and this is kind of the talk I wish someone would have given me like 5 years ago to save me a lot of pain. So a bit of what I've learned on building consensus, why we do it at Facebook, like actually the different pieces of our engineering culture that require it, and then I'll get into kind of my lessons or tips, and then I'll try and demonstrate some of those tips in an actual kind of case study, actually a pretty recent case study, going through a consensus process at Facebook. All right, so let me preface this by saying there are many types of decision-making styles out there, and I'm not here to, I'm not making a value judgment on like whether one is better than the others. I think depending on, you know, the situation, the company, the culture, different decision-making styles make total sense. Military authority, hey, when you're in a trench, bullets flying overhead, you know, you don't have time to poll, you know, your troops to determine, you know, do you go over the hill or do you go over the trench? Seconds can mean life or death. Similarly, you're governing millions and millions of people. Clearly, probably not going to be possible to do consensus. We have to make some trade-offs. Unfortunately, this majority rule is kind of the idea we've come up with. It's you know, as they say, the worst method of governing, except for every other one we've tried. And then there's consensus. I think there's some, you know, pretty interesting situations where we've chosen to use this. I think human spaceflight is probably a pretty interesting example. You know, if you've ever watched NASA TV, before they choose to launch the rocket, they'll have the flight director. He's polling all of his controllers to make sure that, hey, are we go for launch? And, you know, if even one of them says, hey, there's something wrong, you know, that one person can stop the whole show. You know, when there's human lives at stake, you know, strapping on, you know, riding on a rocket with 1.5 million pounds of rocket fuel, probably a good idea. Another area, court system, when we're doing trials, if someone's freedom's at stake, we have juries, and it's unanimous consensus required there as well. All right, so let's, before we get into like consensus itself, I think it's important to kind of learn a bit about Facebook engineering culture and some of the ways we actually encourage consensus building, and in some ways strongly encourage consensus building. So for any of you that have ever been to our offices, we love posters. Like, we really love posters. We have them all around. And I'll kind of walk you through some of these posters and to our engineering culture. All right, so first in favors the bold, be bold. This is really a key piece of our engineering culture, is like we want engineers to speak up if they see something wrong, if they see something that that could be done better. We want them to voice those opinions, and we also want to foster a culture of diversity in opinions. Which brings me to another key piece of our culture, diversity itself. So we're a company that runs multiple services that provide service to billions of people, and we want our culture and our working force and our decision-making process to really reflect this diverse this diverse world that we're serving. There's a lot of features, for example, that we've written that may make a lot of sense in a given geographic area, but they make no sense in some other geographic area. Without this kind of thought diversity, we would not discover these things, we would not fix these things, and that would be a big problem. Bottoms up. Basically, this means that we are empowering our engineers who own the service to make the decisions about that service. I'll get into that a little bit more detail as we get further in. This means direction of a service. For example, the roadmap is heavily determined by the ICs. and individual contributors, sorry, Facebook lingo. All right, so done versus perfect. You're going to see these signs all around our offices as well. Really what we're talking about here is we will strive to get to a V1, and then we want to iterate on that. What we're not usually going to do in our culture is we're not going to go into a cave somewhere, work on something for 3 or 4 years, and then kind of come out with, you know, the perfect solution based on kind of a laundry list of requirements that may have changed in the intervening years. You know, the industry just moves way too quickly in order for us to kind of have that kind of approach. Empathy. This is actually kind of sometimes a shocker to a lot of engineers that join from other companies that may not have this kind of culture ingrained within them. This really means that, like, when someone goes home from work at the end of the day working at Facebook, they should not feel like they've been disrespected. They should not feel like they have not been heard. They should not feel crappy when they go home. This is really, like, that is a litmus test if we're doing a good job in like leading with empathy and treating each other with empathy. So in other words, like, how you accomplish something matters as much as what you accomplished. There's many cases where people might have, you know, launched the most amazing product or moved some metric in some way, but how they did it may have left, like, you know, a large impact crater behind them, and in those cases, you know, that impact is actually kind of it's kind of muted in that case, because just like how they went about that was not appropriate with our culture. All right, so service ownership model. I kind of talked about this. This is my girlfriend's cat. I like to think of, there's kind of 2 service ownership models. The cat model, which is you can own a cat, but anyone who's owned a cat knows you do not have authority over the cat. You can tell them they're just going to do whatever they want to do anyways. I like to think we have the dog ownership model. You own the dog. Generally, as long as you treat the dog with respect, nurture it, you know, more or less you have some authority over that dog. This is kind of our model. You know, if you work on the service, you get to make the choices related to that service. You know, in other words, there's not going to be some, like, director or vice president that's going to come down on high and say, hey, we need this feature, you know, I'm ordering you to go do it. They may say something kind of broad and say, hey, this is a strategy the company wants to execute, or this is like maybe like a large-scale approach that you want to take to solving some problem, but you, the engineer, will be responsible for figuring out how it's done. So they're not going to be prescriptive on telling you, like, hey, this is going to be the layer of the feature, here's a bunch of diagrams, just like go execute this plan. All right, so let's kind of get into the nuts and bolts of consensus building. I think Wikipedia is always a great place to start. So consensus building is decision-making. Consensus decision-making is a group decision-making process in which the group members develop and agree to support a decision in the best interest of the whole group or common goal. All right, so what does it mean? So we generally start out with an idea. You know, I'd say in most consensus process, we're going to get into a group. With Facebook, often this results us having to go back to the drawing board. This could mean, in many cases, we're going to do a proof of concept. As you'll see in the case study, sometimes this means we go off and collect data in order to kind of vet the idea a little bit better. We're not scared of throwing ideas away. There's a lot of reasons why you might want to throw an idea away. Sometimes the idea is just too soon, not the right time. Sometimes, like, for whatever reason, we just cannot get kind of group consensus, and this is a price we're willing to pay in order to, like, foster and not ruin, like, the trust that we have between colleagues and between teams. So I think this is you know, I'll get into kind of some of the challenges, but this is kind of a price we're willing to pay with consensus building. Hopefully, more often than not, though, we actually arrive at some consensus. And we go build whatever it is we're going to build, and we profit. All right, so I kind of touched on some challenges there. Let's get a little bit more specific. So I think it's easier said than done finding that you know, that consensus or that consensus point in a project or an idea. This can be really tough. and it's definitely one of the challenges of consensus building, frustrates a lot of people. Some of the tips I'll kind of talk about in a moment will hopefully help you to achieve this a little bit easier. Speed is a common critique to consensus building. I think some other concepts, like, for example, disagree and commit are out there that kind of tweak consensus building a little bit, try and expedite the process a little bit. They have their own challenges, but you know, they've been successful in some environments. This is one I think some people have a hard time with. I'll talk about this again in a little bit. This is like, people struggle with the concept that they may have like the absolute optimal solution in their mind, but they can't really convince everyone else it's the optimal solution. But you know, they may be right, but in order to achieve the consensus, they may actually have to like settle for something slightly less than optimal. This is something a lot of us engineers have a really big challenge with. I know I did personally. It took me kind of actually like probably a couple, like 2 or 3 years, like working on this kind of intentionally to actually get a little bit more comfortable with it. And we'll talk about this in a bit. And finally, sometimes you just can't achieve consensus at all. And as I kind of spoke about in the last slide, the price we pay is, you know, some really great ideas actually we either can't do yet or we can't do them at all. All right. Let's talk about some anti-patterns. So part of my job, I actually try to like be the change I want to see. I actually started like mentoring, and actually we developed a bit of a tech lead training program inside our org. And these are kind of some of the anti-patterns that we've seen in the past, and I think since we've been starting to kind of be more intentional about our training around consensus building, we're seeing less of it. So what were these kind of patterns? Avoidance. So this is the, you know, maybe you have some great idea, people maybe, you know, aren't buying in, or you're struggling winning them over. A lot of time people just be like, screw it, I'm going to go do it anyways. It's kind of maybe the field of dreams approach. If you build it, maybe they will come. Unfortunately, much of the time they don't come, and then you feel like you've wasted your time. You can be really frustrating. On the other side of the coin, I think it's important to know that like there's always two sides of consensus building. It's sometimes maybe the person that created the idea, but it's also those of us that maybe are the advising on the idea, or maybe we're a stakeholder on the idea. This is like a common not so great anti-pattern that some of us may have used in the past, which is kind of what I call the landmine critique or technique. The idea is like someone's proposing an idea. It's the dumbest idea you've ever heard of in your life. The odds of this succeeding are like precisely 0. Why even bother engaging with them? This thing is going to crash and burn like the day they launch it, right? Like we can just cut to the chase. I'm going to go work on something else. The problem with this, of course, is like some poor soul or souls is going to waste months and months of their time. The company may be wasting millions or tens of millions of dollars on the project. So it really, it's really important for engineers to really participate in these projects, like these consensus building process. And even though it may be tough and hard to convince them that maybe this idea needs to be changed in a certain way, or maybe shouldn't happen at all, I think it's important to like not landmine your colleagues in this process. Authority. This one, we actually make this pretty tough at Facebook. We have a no-level environment, so if you're an engineer at Facebook, you actually won't know what level they are. They don't tell. It is completely hidden. So we actually kind of take this ability away from our engineers on purpose. This is like kind of a very explicit way that we really try and encourage consensus building and avoid people using authority. The problem with authority is you get into this world of like cognitive dissonance. So this is like, hey, someone's asking you to do X, you actually don't believe in it, but they're coming over the top of you with authority and saying like, just do it anyways. Now you've got those nights when maybe someone has done this to you, you're tossing and turning at night, maybe you can't sleep. That's cognitive dissonance. That is your brain trying to like square the circle, trying to like figure out how to kind of reconcile this thing you have to do with this thing you actually don't believe in. And the result of that, no passion, you're not going to put the extra effort in, quality could suffer, you're just not going to wake up in the morning and want to actually, build this thing that you're being asked to build. Bike shedding, I think most people are familiar with this one. You just, maybe you're in that room, you're discussing the idea, and you end up talking about some part of the solution that is actually not super critical to the outcome of the project. I think in these cases, we just need to know, when we're getting into that bike shedding scenario and just kind of back off. Where the bike shedding, for those who aren't familiar with it, it's kind of the idea of we're building a shed and we start arguing over the color of the shed, but not actually the design of the shed. The color is kind of irrelevant to the shed, at least from an engineering point of view. Maybe designers might differ. All right, escalation. I think this one is pretty common anti-pattern as well. Maybe I'm friends with a director, maybe I'm friends with a vice president, or maybe my manager is more powerful than your manager, and I'm just going to go over to their office and say, hey, we need to do X. Maybe they trust you more than they trust maybe the newer engineers, and you just escalate and, have them announce this at the next all hands or something like this. My view on this is I think this works probably maybe once, maybe twice if you're lucky. At Facebook, we make this pretty tough in that we actually make it pretty easy for people to change teams. So if you start kind of, pulling escalation on people, you could find yourself a tech lead with no one to lead, because people may be just rotating off your team. So I think this is, it's not a shortcut that we like people taking. That said, there are times to do this, and I'll get into this towards the end if we've got some time. All right, so build and maintain trust. So I think trust is super important between engineers. Frankly, those that are actually that kind of avoid consensus building because due to the speed, I would encourage them to really think about how much trust they have on the team and how much trust they have between teams. Because frankly, I think having this trust is actually one of those things that actually allows you to move quicker. Classic case of this is people actually do consensus building on their team really, really well usually. You see these people every single day. You see their code every day. So, when that engineer comes to you and maybe you've got to build this feature, you've got to fix this bug, and, in many cases, it may only take 1 or 2 meetings to actually achieve consensus on how you want to write this feature. And a lot of that is because you're willing to take a lot more leaps of faith with people you trust. There are just details you don't need to know. Maybe you've seen this engineer knock various features out of the park time and time again, and maybe the way that they're describing their implementation isn't quite how you would do it, but because they've got this track record, because you have this trust with them, you're gonna make that leap of faith with them. Let me back up. Okay, so building a track record, I think this one's also important. This is where a lot of the time we see the too soon case. In this case, there we go. In this case, sometimes there's just not enough trust between teams to actually do the thing you want to do. I think this is a perfectly reasonable thing to kind of recognize, and in some cases you just have to take a step back. You may have to actually if you've got some really kind of the larger idea, kind of the more kind of groundwork or foundational work you may have to do ahead of that. So you can, if there's this idea you've got and you really want to go chase it, I think you need to look for opportunities to build trust with those kind of partner teams. That builds the trust, and then that helps them kind of take those leaps of faith with you that I just kind of talked about. Language, I think this is kind of a detail that a lot of us are pretty busy, we're in a rush, and we can get sloppy with our language. This can actually kind of erode trust bit by bit. We get into these us versus, or us and them kind of mentalities when, we're all in the same company, maybe we're in the same org, we're really all trying to achieve some, greater goal. So I think it's just important to kind of watch your trust when or watch your wording when you're making posts. And finally, when you've got this trust, you need to nurture and protect it. This allows you to move quicker in the future. So if you've done some big successful project with 2 or 3 teams in your org or in your company, you'll probably find the next time you have to go do a big project with them, since you've built that trust and you've actually got some experience with them, it's going to just allow you to move quicker. So I think it's important to nurture this trust once you've got it and protect it. All right, shared view. So this is one where I think a lot of us often, considering how many different graphics you can find on Google of this, I think it's a pretty universally problem that people have. And this is the idea that we may be looking at some problem or some solution to a problem, and we may not even really all agree on what the big picture is. In a case study, I'll get into kind of a really concrete example of the different kind of stakeholders in this project actually looking at the problem completely differently, and we actually have to step back and actually solve that first. All right, be intentional about alignment. So what do we mean by alignment? It means we want to agree on different aspects of the problem that we're trying to solve. It means we want to agree on what the solution requirements are. So, is it scale? Is it reliability? We want to agree on the unknowns and the non-goals. Don't assume that what you think are the non-goals or what your stakeholders agree are the non-goals. Same goes with unknowns. As well as data. Often people will actually be showing, I've seen a ton of charts, I've seen a ton of tables, and sometimes we can be looking at this and the impression that I have in my head on that chart is completely different than what they have. So I think it's important, also the confidence level of the data, maybe the way they're speaking, it kind of, makes you believe that this is scale amongst a large portion of your maybe your customer base, when actually it may be just a sample. So I think it's important to really understand what the confidence level of the data is, and making sure that you are interpreting it the same as your teammates or your stakeholders. And finally, expectations. I think you want to align on what those expectations are. So what is the expectations of the project? What is the expectation of your partner teams? Be intentional about this. Take the time to do it. Okay, so this one I think is a little bit harder, and I think this one's been probably a bit of a journey for me to actually learn how to be good at this. And that is when you're the one that is trying to build consensus on something, you actually have to take more of the mindset of being a facilitator versus trying to push maybe the solution that you actually think is the best solution. I think at least initially, step back. If you do a good job at this, people may not even realize what your view is on the solution. So in this case, you can kind of reveal what you think the problem is, and you can say, hey, we need to go solve this problem, but actually try and resist the temptation to actually really being vocal about what you think the solution is. It can just end up kind of shutting down discussion. There may be people that really, really look up to you, and it can kind of shortcut, you can kind of shortcut the process in their mind by just kind of, defaulting by agreeing with you. So what that can mean is have strong opinions when you get into this. So when you are revealing what you when you are revealing what your belief is, or on any of the things being discussed, but being willing to move off of those opinions. The other piece at Facebook, I think this is probably a really key piece at Facebook, which is focusing on the data versus theory, opinions, or experience. At Facebook, the problem is you will find experts on nearly everything. You will find people that are equally qualified on almost the exact same topic, and they may have completely opposing views on something. So it's not as simple as, well, we're going to seek out the expert on X. In many of the discussions we have, we may have 4 experts on X. And they all may have different ways of approaching it. Even if any of you participate in the kernel community, you pretty much see this all the time. There's just a lot of really smart people in almost every area, and there's going to be just different approaches. Same thing goes with experience. Everyone may have different experiences, so they may have seen some things be successful in their environment, where other people may have seen something fail. So in our world, we really want to bring data to that, which is specific to Facebook. In this case, it could mean it's a proof of concept, or as you'll see in the case study, we may go back and look at historical data to actually figure out what the right approach is. So being a dissenter also, or being a facilitator also means making sure that in the consensus building process that you're not you're kind of creating a good environment to actually get this thought diversity. This means you actually want to move towards your dissenters and your critics, not away from them. However tempting it might be, it's really important. The reason for this is eventually the dissenters and the critics will come out of the woodwork, and you don't want to do it when you've basically written code for 6 months and just spent another 6 months maybe releasing. You want to really talk to them early on in the process. All right, consider the venue. This is like kind of a common, this is probably one of the biggest mistakes I made when I started out, which is my manager would be like, hey, go solve this problem. Just get everyone to a room. Just like, just get everyone to a room, have a big chat. You'll come out with like, you'll come up with a design and, we'll be way to the races next week. Instead, it actually ended up kind of often ending up like this. If you can't actually, if you don't really, if you go into that room kind of having no idea what people actually are thinking about or what their opinions are on your proposed solution, or what even the problem is, it can just end up being kind of a pretty big disaster. So I think, you need to think about doing it differently. So what should you do differently? Initially, I actually kind of think about this as like kind of being something of a diplomat. So if you've ever seen like, when they negotiate trade agreements, they show those lovely signing ceremonies. Well, the reason those signing ceremonies are so lovely is because they've actually done, months and months and months of groundwork and legwork behind the scenes. And what they're really doing is they're kind of meeting with different stakeholders separately. So, in a trade agreement, they might be meeting with like dairy farmers and textile manufacturers, and you kind of got to think of your role a little bit like that. So in this case, identify, maybe it's not dairy farmer and textile, but it could be like the different stakeholders on the given project, and kind of like really just meet with them again. Don't put out what, maybe what you would advocate being the solution, but just like listen to them and say, hey, do you think this is a problem? Do you agree this is the problem? What do they think the solution might be? And this is really demonstrating also empathy to them. So you're really being intentional about really getting in their shoes, understanding how they see the world. One-on-one. So I talked about like moving to dissenters. You don't want to be doing that in a group discussion. This can get people just simply behave differently in a group than they will one-on-one. And if there's something really contentious, like the last thing you want to do is get contentious in a group setting. It's probably unprofessional, and people can in some cases feel in some cases humiliated or just really disrespected in that kind of an environment. So I think it's important, have a one-on-one, understand their point of view, and move to those engineers that might be vocal and disagreeing. And you'd be surprised what you find out. Most engineers are, maybe vocally opposed to something because they really, really care. These are people that they do not wake up in the morning and figure out like, how they can, 10 ways they can say no. They really care about probably your company, your org, and what they do. So it's really important to like, we have this thing at Facebook like assume good intent, and that's what we mean. All right, avoiding the local maxima trap. This was one that was not super obvious to me when I was starting out. I used to see the world like this. I had, maybe there's some large project I'm involved. I'm working on some feature, and I've got in my head what the optimal, solution to that feature might be, and I'm gonna like fight tooth and nail to have this feature done in the way I think it should be done, because maybe it's gonna save resources or be more efficient or quicker to do. But what I wasn't really seeing is, hey, there's actually this giant project that we're actually trying to achieve. And what we really want to do is get to this end state, and maybe this feature that I'm working on is actually, important and critical, but, you know, whether we do it like my super optimal way or the way actually the group is really pushing for, it's actually not that big of a difference in the big scheme of things. So I think it's important to kind of think about, like, are you pushing for some global maxima? Or are you really arguing for some local maxima? And, you know, if indeed it's a local maxima, like, be okay with just something slightly less optimal in order to kind of move forward. I think that's, you know, really important to really internalize. All right, a case study. So this was a process we went through, I guess, last year. We were we're actually in the process of improving the way we do load shedding, one of our storage systems. And initially, when this all started, there were various leaders in our org kind of came to me and were like, hey, like, how can we make throttling a better experience? So that's kind of maybe the customer view. You go talk to maybe the service owner, and they're like, you know, that's great, but like different customers are asking for different features. So like, you know, what do we do? You know, I talked to, you know, team X, and they're asking for one feature. I talked to team Y, they asked for a totally different feature. So we've kind of, you know, this is a case where like we lack consensus on what to do. As it turned out, we also lacked kind of agreement on like what the problem was. Was it some people were like, oh, we're solving resource contention within a customer. You know, so say you've got, you know, I work in the data warehouse, so imagine you've got a Spark or Presto query, and maybe these different queries are like colliding in terms of their resource demands. So maybe that's, you know, some people had that was the view that of the problem we were solving. You know, maybe from the storage team's point of view, they were like, no, we're solving resource contention between customers or tenants in the storage system. Others are like, no, we're solving, you know, clarity on how the load is shed or throttled. So these are kind of things we need to like agree on the outset. Once we did that, so in order to do that, this is where, so once I kind of figured out that, you know, not everyone was seeing the world eye to eye, it was pretty much kind of roadshow time. My teammate Dan actually calls this like gathering the roots. Apparently there's some ancient Japanese axiom around this. But it's actually pretty good wisdom. So initially kind of just met with, you know, the XFN teams, or like these are basically the stakeholders of this project, figure out what everyone's views are and why. I had a ton of one-on-ones. Actually, there was kind of a process where we kind of went back and forth on this, had one-on-ones, go meet with stakeholders, have more one-on-ones. And the idea here is just kind of inching people towards consensus before we kind of get people in a big room to actually kind of iron out the final details. So you can kind of think of this, so by the time we got in this big room where we were actually kind of all deciding if this was the direction we wanted to go, most of the major issues were kind of already fairly well aligned. At that point, it was really, you know, some more minor disagreements that, frankly, we just needed to get everyone in the room to actually to get a decision on. The other good news is because a lot of these larger decisions are already kind of pre-aligned, people are just more willing to move on some of the smaller aspects of or smaller decisions that you need to make once kind of the bigger questions are all resolved. All right, so even then, we got to a point where we're like, okay, we've got, you know, what we think is a plan, and then one of our leaders kind of comes and is like, yeah, you know, this is great, but you think this will work? Some engineers would be like, you know, do we really need feature X? Are we trading problem X for problem Y? In order to actually kind of answer some of these questions, we went back, looked at some historical data, and I actually kind of simulated this solution, or like the throttling model that we were actually coming up with, using historical data, went through and looked at, you know, various cases where, you know, the throttling would have kicked in, and actually looked at how it would have impacted the different systems in our stack, and then showing that that indeed modeling, or like bucketing the I/O in a certain way and having limits along certain boundaries would actually indeed work based on the data. So I talked about the local maxima trap. What did it actually look like in this case? So what were some of the things that maybe in my head I had a certain optimal solution, but things that I actually had to compromise on, or my colleagues had to compromise on? So throttling granularity. Some people, if you left it up to some of the customers, we wanted to slice and dice throttling 10 ways from Sunday. We wanted, potentially millions of different buckets to put I/O into. But we have to achieve some sort of a compromise with our colleagues, because obviously the complexity of actually pulling that stuff off varies depending on what we're going to do. The throttling boundaries. So where should the boundary of throttling be? Should it be at a high level? Should it be between tenants? Should it be between maybe buckets that are within tenants, or should it even be below that? These are things we had to discuss and compromise on. And then there is, of course, as in any project, implementation details, different systems that we build our store systems on. They're sharded. They could be sharded in a certain way, which actually, forces certain decisions on you, or if you wanted to make certain changes, you may have to re-architect things that are lower in the stack. So we have to think about those things and make those trade-offs. All right, so once we went through data, basically we gave some people some time to digest the data. This actually ended up being a dashboard that people could interact with. They could actually go through the different scenarios. At that point, had more one-on-ones, worked to close more of those gaps based on the data that they were seeing. In some cases, actually, one of the more interesting questions that I sometimes will ask when someone is just really not wanting to buy in on something. I think one of the more interesting questions you can ask is hey, if you can change anything, here's the gavel, you can do anything you want, what would it be that you would change in order to buy in on this? And I think this kind of gets people out of that mode of kind of saying being Dr. No, and actually thinking okay, what would it take to get to yes? And I think this is kind of if you really have a situation where, just no matter what you say or no matter how much data you bring to the table, I think that's a key question to ask people. Finally, we had more XFN meetings, or basically meetings between stakeholders, closed the smaller gaps, we achieved consensus. And then the final test is really is everyone willing to put their name on this thing? So when we do a consensus process like this is not something that I am putting out. This is not something my org is putting out. This is something all together we are putting out. And this is the names on all the engineers that were involved in this is on this thing. And it's a really good gut check whether you actually did achieve consensus, because once this thing is written up, people have gone through the draft. If they're not willing to put their name on it, then that's a big red flag. That means somewhere along the lines something went wrong. All right, got a little bit of time, so I'm going to go through one extra thing. So I kind of talked about disagreeing commits. I kind of touched on this at the beginning. This is kind of a decision-making process that was popularized and I think well used at Amazon. One question, so when I actually started kind of learning more intentionally about consensus building, we have this kind of yearly summit where a lot of senior engineering leaders get together at our company, and I asked them, okay, consensus building works, I'd say, most of the time, but, what do you do when it's just, not working at all? And what would we do that is, what does the decision-making process look like that may require some sort of escalation that is consistent with our culture? So we actually met as a pretty big group, and this is basically one thing we came up with. And you can kind of think of this as a take on disagree and commit, but there is, I think, a really important tweak to the process. So we have the attempts at consensus. Maybe we do some POCs. maybe we get consensus, but let's take a look at the case where we don't. In this case, what we decided is actually having the idea of a trusted arbiter. I think the key difference here between disagree and commit is really this. The idea here is someone who is going to make this, basically make the call here, is trusted by both parties. The reason trust here is important is going back to the idea of cognitive dissonance. If you trust the person that ultimately has to make this hard call, you're probably going to be able to sleep well at night, that they, knowing that they made the call, versus maybe someone who has, an interest in the way the decision was made. For example, if the person making the decision is the person that is advocating for a given project, of course they're going to advocate and rule that their project is the best one. The idea here is you want someone a little bit more neutral, who is trusted by both groups. Sometimes people are like, well, what if I can't find anyone? And, my answer there is eventually, hopefully, if you up, your reporting chain, you will get to some person in your company, or ideally maybe an engineer who's fairly senior in your company, really well respected, where if they're given enough data and context on the decision you're trying to make, that everyone will be will be able to live with it. In some cases, the trusted arbiter may choose, again, they may come back to the conclusion not ready, not now, or not ever. In some cases, they may just decide what the solution is and go build it. But in other cases, they may choose to bet on both. And I think if the resources exist in a company to do this, I think this is something that, and I think this differs from disagree and commit on this count as well, which is, in some cases, build both, see what happens. At least get to a POC stage. Competition can be a good thing, and again, this going back to data, you're going to get a monstrosity or monstrous amount of data from a POC that you're just not going to have if you didn't do it. All right, so final thoughts. Consensus building is challenging. It can be time-consuming, but I think it's worth it. It builds trust between teams and within teams. It's essential for a healthy bottoms-up culture. If you've got a bottoms-up culture, it's pretty hard to do top-down decision-making. It just won't work. And it helps foster inclusion and diversity of thought. If there is a small select group of people calling the shots, it's pretty hard to have everyone heard. And I think ultimately it results in higher confidence decisions. Just coming back to the the mission control example, they need to have absolute confidence that things are going to work. When they're launching those rockets, for large scale projects in large orgs, or in the open source community, when you're working on potentially a feature that could affect tens or hundreds of companies using your open source, I think you really do want high confidence decisions to be made. All right, questions? And I'll just repeat the questions, and we'll avoid passing the microphone because news.
So how do you handle projects that naturally would flow from top down? So things like resource constraints or security or something that's kind of a top-down mandate on what needs to happen? What does that look like?
Sure. So the question is, how do we handle some decisions that absolutely just need to come from top down? For example, security or kind of policy-driven decisions. So yeah, that's a fair point. Again, there the way is to avoid anyone being prescriptive. So in our culture, it's perfectly fine for Zuck, for example, to get up there and say, hey, this is super important. We need to execute on this. But what he's not going to say is and you need to architect it this way, or he's not going to have one of his lieutenants kind of come up with some architecture and say this is how it's going to be architected. In fact, if you were to go into what we call big bet reviews, where people are actually kind of giving a status update on some of these large projects, you may end up having a leader simply push back on you and say, hey, like, no, that's your job. Like, that's not my job to go figure out, like, you know, how to, like, architect this. That's your job. So I think on some of these things, like, it's really the type of decisions that are coming from top down are not going to be, like, you know, getting into the weeds of, like, how it's going to be done. So execution is really in the hands of the engineers. Kind of policy is definitely maybe coming top down because, frankly, at our level, like, we're just not going to be in a good place to be making policy decisions or strategic decisions. So it just, you know, those things just kind of make sense. That said, I'm sure even, you know, at those echelons, I suspect there's consensus going on there too. I'm pretty sure that those folks aren't just kind of like, you know, coming out of their house one day and say, hey, we need to do X. You know, they're probably doing some consensus building amongst people that they trust, and, you know, at those levels. Yep.
So when you have two conflicting opinions and you end up with an actual and a hypothetical one, one of the issues I usually see is that when you start building it, the actual one faces critique and faces problems, and the hypothetical one remains perfect because, you know, if we did that, that would have gone perfectly well. So that there's a lot of people who avoid voicing their opinions a lot because they fear being responsible for the actual solution. So how do you go about diminishing this problem?
Okay, so is this, so you're asking, when you're making a decision between say, some concrete solution that exists today and maybe a theoretical solution that may exist in the future, or?
Pick one direction to go, right?
Yep.
Do A or B.
Okay.
If we do A, every time A faces a problem, someone's going to say, B wouldn't have that. You know, so it
Yep.
only keeps increasing the pressure.
Kind of like the grass is greener. Yeah. So I think in terms of so one, I think this is actually a big challenge. I think when possible, I think this is where the POCs are really important because I think this is where like. Also, like, empathy is important, because I'm like, we've all been junior engineers at some point in our careers, and I think more senior engineers probably catch that a little bit sooner, because they've been through enough projects where, you know, it seems super, or even, like, built a project where it seems super rosy on the outset, you kind of get into actually building this thing, and then, the problems that you did not anticipate start cropping up, and it ends up not being maybe as reliable or scalable as the thing you intended to replace. So some of this, I think, is experience. So I think this is where, like, empathy is super important, is one, to, like, acknowledge to those engineers, like, hey, like, even in my career, you can, go through your own experience and say, hey, like, here's some examples where I built things where I thought it was going to, be better than the thing it was replacing, and it didn't, and here's why. You can encourage them to, like, build a POC, or proof of concept, and actually see if they can collect, like, generate some data. That also may get them far enough down the road where some of these kind of edge cases will start to pop up, and they actually have to start thinking about them. And if they don't pop up, then that's great. Then like, indeed, the grass is greener on the other side. So I think those are kind of the two approaches that I would take. Yes?
So you talked about the, like, structure of the org at Facebook. How would you say we could apply this methodology in an organization where you don't have that, where there is very much like a hierarchy and an authority-based management style? How do we take some of this stuff and implement it in a structure where, people are going to pull rank or say, no, because I said so?
Yeah, So some engineers have come to us sometimes and say, hey, like, the fact that you're training us is great, and you have this training program is great, and things like that. But they say, hey, my experience is actually like, maybe there's like a tech lead in their org or their team who is just not, we're a big company, so there's going to be pockets where some of this stuff is not happening the way it should. So in those cases, the advice I usually give is, one, like, seek out allies within your company or your org who want to, like, operate in this way. In our company, it's pretty easy because, like, it's just, there's going to be a lot more people that are going to be consensus builders than otherwise. The other thing is, you can build consensus on the other side. So if there, for example, there's, maybe a top-down decision coming at you that's maybe super prescriptive, then in that case you can actually, build consensus on, the side that's saying, hey, like, maybe we've got to slow down, or maybe we need to, like, POC this, and try and get consensus from the other side of the table. And in those cases, it may be it may give that, that the person that's making the authority-based decision some pause and say, okay, well, this isn't just like one engineer who is like opposing this. This is actually like 4 or 5 engineers who are all opposing this. So I think like in consensus you can use like to get something done, but you can also potentially use it put the brakes on something that may be either top down or just maybe not such a great idea. Yeah. Cool. Yeah.
Is there a minimum team size where this can be implemented in your experience?
So the question is there a minimum team size where consensus building like kind of works? So I'd say that's so at Facebook at least I can speak to our teams. So teams I would say vary on the small end, maybe 3 engineers. Middle of the road might be something like 5 to 8, and then larger teams might be 10 to 15. In our case, generally if teams get a fairly big size, we'll actually break them down into pods. Is kind of a common kind of structure that we see. And within at least those pods, there should be relatively good consensus building. And then between pods, you should be able to, have enough trust between, like, say, the tech leads of the different pods, where it will really be their job to, like, build consensus between each other. So I'd say, like, try and scale it up. And the idea here is always going to be, like, maintaining the trust between kind of these like, threads between the different parts of your company. So I'd say it can work at almost any scale, but like the trust is going to be super important because like ultimately in order for it to scale, you have to have people that trust each other. So like when the tech lead came back from that meeting and says, hey, on behalf of our team, I agreed on X, like hopefully everyone trusts that engineer enough to do the buy-in part. In some cases, I think another good behavior is like, you can always do the I agree, but like just say, hey, I do need to go back and consult my team and make sure everyone buys in. And sometimes that simple act of going back to your team and saying, hey, I didn't like sign our life away on this. I really am coming to you for like any of you in the room here can have a veto here if you really feel strongly about that. And often just you being the tech lead and like giving them that kind of power not only shows respect and empathy towards them, but in many cases, just by saying that, they're gonna, unless they really, really disagree, they're probably gonna trust you and kind of take that leap. All right. Thanks for coming. And if you have any other questions, feel free to pull me aside. I'll be on the floor or wandering around attending talks.
Check 1, 2, check. Check 1, 2, audio check.
is going to be HTML. Okay, so now what we'll
do is, this is a dot file specified. So now what I can do is I can get out this and I can see that I have in JSON. Okay. So now what we'll do is, this is a dot file specified. So now what I can do is I can get out of this and I can see that I have this dot file here. What I'll do, the command line tool is also called dot, and so I'll give the type of output
Check, check. Mic's working fine. Oop, except for that part. I'll try not to do that anymore. All right, everybody. Hi. So we'll go ahead and get started, and then, which is a good way to get done sooner. So we, you know, if we want to, this is fine. I mean, I'm happy to be here. I'll talk all day. So, yeah, I guess I already told my joke about having been in this room all week, so, you know, that one's done. So hi, I'm here today to talk about the Open Source Way, which is a guide for community management best practices. And I'll, you know, go into what all that means. And my name's Karsten, and I'm a community architect on the Red Hat's Open Source Program Office. And that's enough about that. If you want to know more about that stuff, come talk to me later. I'll also be in the expo hall all day tomorrow, as long as it's open. So what we're going to talk about today is what this thing is. Oh, how interesting, the render to, this is interesting. I may have to abandon this and go, I didn't look at my ODP and it didn't like the font. You know, I'm going to pause and I'm going to switch over to the PDF, and that way you can actually see all the stuff that's on the slides. And I will just have to mutter along somehow. No. Oh, how do I do this thing where I pitch down? What's presentation mode? I don't know if it actually, does this actually have a present mode? What's this? Slide pane, no? Oh, I can turn the slide pane off. Oh, is there a hamburger menu over here? And I can't read sideways. Do you see anything that says?
Yeah, present to slideshow. There, you're on it.
I'm right,
Oh,
right
yeah,
there.
there you are.
Ta-da! Thank you, everybody. Good audience participation. You are now contributors to this talk. I appreciate that. That's the whole point. So let's go on from there. And yeah, I may have to occasionally glance over I know all this stuff, but I might glance over to look at it every once in a while. I promise I won't read from my slides. So today I want to talk about what this thing is, what this guide is, what the vision for it is, the intention, you know, kind of going from here. And part of that is to talk about how we got here, what's the history of it, because that kind of tells the story, and also as sort of a tale of what happens in open source, where ideas come along and they're, you know, it's the right time for them, but maybe not the perfect time for them. And so the present, where we are today, what's going on right now, and one of the hints I'll tell you is I'd intended that we would have a little, when I submitted this talk, our schedule was that we were going to have a little bit more released by now. So, you know, so I'll talk about where we are today. And then what's next, what's coming, who's doing what, when those things are happening. Make sure I'm on. Yeah, there we go. Okay. So here's the vision, and I'm actually going to read this because I wrote this morning because I realized we didn't really have a really good one for it. So our goal is to create a community management best practices guide for open source practitioners. And that doesn't just mean community managers, it means anybody who's practicing open source in any way, right? And written by and from the experience of those same practitioners. So any kind of community practitioner, not just open source, might have something to contribute or to learn from this. And in the process, foster a community of practice that will maintain and grow the guide. So community of practice is this thing where people who are interested in learning how to do something better get together as a community and learn amongst themselves how to do things better. So this kind of matches into this idea pretty well. So let me get into the quick history. So okay, so that's the overall vision of what we're trying to do, right? And as I go along, I'll do some outline. I'll show you what's actually going to be in the guide, what's going on, where we are, and so forth. And that'll help kind of fill in that vision to show you what we really got. So about 10, 11, 12 years ago, well, I guess it's 2020 now, 11, 12 years ago, I worked with a number of colleagues at Red Hat and the community architecture team, Greg DeKoningsberg, Max Spivak, Mel Chua, Sebastian Dizales, all of our interns, Ileana Weller. We all collaborated on some ideas around a book we wanted to do because we had this experience of constantly answering the same questions for people over and over again. We thought, if we could answer this for Red Hatters in one document, how much easier our life would be. And the moment we started to outline it, we realized that this thing had to be, basically, if it's going to purport to give best practices for how to do an open source community, one of those best practices would be don't write a secret book by a small group of people and keep it inside your company, right? It would be do this as an upstream, something like, this whole project. So every one of those questions sort of answered themselves right away, and we realized we needed to create a project where this all kind of came from, and then Red Hat would put all this there, and ideally we would collaborate with other people outside the company to improve what was there, and we would all learn from it. So we did the first version of the book, and it was intentionally incomplete. I had a lot of here come in, work in this area sort of things, and I did a little work for about a year to publicize it and get interest, and people were using it, but we didn't really get a very large contributor base. I had some good comments and things that came in, but it didn't really get very far. And then priorities shifted and things moved on from there. And that was okay because the book was serving the purpose it needed to at the time, and it helped for a while. It didn't solve all the problems. But in the time since then, there's been an evolution, I'll say, in open source development in terms of people understanding what it is and why, and that you want to do it. And also there's a lot of stuff out there about how to do it, but this concept, this idea of why, like why you do something has always been missing. And then obviously there's no book out there that's written collaboratively by open source practitioners about how to do open source, I think. I think I can still make that claim. There is now, though. That's what we're working on. Is that what I was expecting to see next? Yeah, so why something is a best practice good. I just wanted to make sure I said that part. That was important to me. So in general, this is a top-level outline of what the sections of the book are going to be, or are right now. We're starting to get, there's some content coming in here. So we're going to have sections. The sections will have chapters. Everybody who writes in the book will work on a chapter or one or more chapters, either by themselves or collaboratively with a few other people. We have some of those chapters are blank. Some of the ideas we have are blank. Some of them have got some starter material pulled from other sources. So there's things to work with. And so these are the sections that all those chapters would fit in. Let's see. So the first one, the Community 101, or the introduction, is the basic idea of what an open source community is, or what's community mean in an open source context. It's probably the better way to say that. And then also an important one, why you would have community, and to look at those situations where maybe you don't need to have a community, and that's okay. And not every piece of code out there needs a community around it, right? And similarly, something that came up in our workshop yesterday is this is also a good location to have a quick start. Hey, you've got 2 or 3 friends, you're working on a project, you want to make sure that you're starting things off right so that you don't create community social debt going down the road besides technical debt. So here's a quick start. And so that's something we're going to add in that came out of the discussions in the workshop yesterday. And then from there we get into this area that I think really demonstrates the bias of the community teams at Red Hat. What we see as the way to grow an open source software project, that we want to have a good contributor base and good user base, is by focusing on making something that people want and people will use, and they have a good user experience. And making sure that when anybody from that growing user group comes to look at your project, they are able to learn things about it really quickly. If they're the kind of person who likes to participate, maybe go on a web forum and ask and answer questions, maybe they like to come to a conference and give a talk, or just talk to people in the hallway about how much they like a particular piece of software and so forth, then those participants have got everything they need right there. They don't even have to ask questions or find something, they can find those pieces. And as those kind of people grow and become contributors, the idea being that contributors don't just parachute out of the sky, but there's somebody who generally you cultivate them from within the community, or people come along. And then how do you grow those contributors on what's going on inside there. And then this community manager self-care is a new section that came out of a Birds of a Feather session we had at FOSDEM last month. One of the participants, audience members, asked about this, and it became, again, immediately self-evident in that moment that it was an entirely new section that was going to need multiple chapters within it. And again, something that really, it speaks to the community of practice, it speaks to taking care of ourselves, it speaks to how the kinds of things that, what's the old adage about the carpenter's roof leaks kind of thing, you know, that we always forget to take care of ourselves. And that if this is going to include best practices, it has to include taking care of ourselves. And then beyond that, we another section that at least our team knows that we would need in there is measuring success. You know, we have a kind of a corporate role in seeing that stuff, and there's a lot of people care about that sort of thing. So there's a pretty good area. I think a lot of work is going to go in there that will be new, helping gather together all the different ways and techniques that are out there and best practices around that. And then we have this catch-all at the end, avoiding pitfalls and learning from mistakes. And this is a little bit of a, by catch-all I mean this is stuff that maybe the stories and the bits that didn't fit anywhere else. They didn't quite make the cut, but they're really good ones to have. And we just want to make sure that they're in here, these kind of common things that come through. So yeah, let me just, you know, expand upon this a little bit. I said some of this, but I'll just go through it. So these, you know, what the sections are going to look like, and the different chapters within it. This quick start checklist, that's a new thing. Attracting users, guiding what participants want, how they can help, and so, you know, these kind of, and these are chapters that we envision being in there, but this doesn't mean this is the only chapter that will be in a section. Somebody could come along and say, you know what you're missing is this, and say, great, do you want to write that chapter? And now we've got a new one. And in addition, we're realizing that people might want to make their own remix of this, and so everything in our repository is designed and labeled so that you can. I can show it to you in a few minutes, but basically the idea is the tooling's not there, but the idea is that you could go through and cherry pick and decide what you wanted in your own book. Maybe you wanted something that was focused on people who were doing hard development or on people who were trying to market with community in mind, and so you would maybe just pull out all the stuff that didn't matter to them and build a version that did. And then also, I think I can mention this as well. It's a good time to mention it as well. Within each one of these chapters, the idea would be that the overarching content would be applicable to kind of any free culture situation a little bit. I mean, definitely focused on open source software, but in a way that can be applicable to other things. And then specific examples, those stories that tell why people do things, those can be swapped around depending on what target or what audience you've got. So, you know, this is kind of a little broader vision. Our 2.0 version is we want a whole pass of the book that's complete. And then some of these things are just additional ideas that will get caught in there. And yeah, let me expand out a little bit on what the idea of growing contributors. An important one is being able to identify what a contribution is, the kind of thing that you'd want to have on the front of an open source project that says, hey, documentation is a real contribution. Hey, marketing is a real contribution. Please come apply your skills here. And then just other things about how, getting a project organized and doing onboarding. So that came out of a conversation yesterday. I had somebody come up who she has experience in community organizing, but not in but her community organizing is around it. So she had this I don't know if I fit in here or not, and it sure would be nice to have something that tells me I fit in to this project right here. And I was like, yeah, because of course I would tell somebody else that advice for their project. Make sure that people know. And so while she was here yesterday, she opened a new issue against the README file so that we will go and include this. So when you come to the project as it is right now, it will talk about if you have any kind of experience that you're worried about applying, come in, we'll help you figure out how to apply it. And then other things that are important, legal and governance, community roles. I forget what migrating code is, but it's one of those things that is important to somebody, so we've got a chapter for it. Just being honest, I forget where that one came from. So yeah, here's the community manager self-care, that new section. Finding healthy communities and developing a metrics plan. That's sort of the way that our team has looked around when we're trying to measure what's going on in the community, is to have an idea of what healthy means versus not healthy in that context. And then how are we going to measure? With a human, you've got body temperature, and you've got, are your cheeks flushed, are you coughing, or anything like that. With what's the equivalent with a community, right? Yeah, and like I said, homo tell the extra stories, and what that means is when I was describing that kind of overarching way a chapter might be built, where you've got the story at the end, that Y example, this is where all those extra Y examples could drop into, and maybe it becomes a place you can cherry pick from when you're doing a custom chapter. We'll have to see if that works. And then proof and references, like anything we've got that's source material that we want to be able to point to, so that we're not duplicating things in, and what the community recommends as best references to use. Okay, let me take a breath. I said a lot of stuff. Is there any questions at this point in time, or I can just keep flowing? Okay, cool. So let's give you an idea of what's going. I mean, so that's what the book is, and when the book's ready, you'll be able to pick it up, and you can use it for that. And it, you know, whatever purpose, whatever place that you might want to, whether it's so you can practice for yourself how to have how to improve or look for ways to improve your open source community, or you can, you know, something you can show to other people for like here, this is, the book says we need to have this kind of thing. We need to have, you know, we need to be transparent or something, and here's why, and it's got all the pieces there for that. So where we are right now in the present is we have a Git-based workflow, and we've been focused in the last several weeks on having everything set up so that when this workshop happened yesterday, if somebody wanted to sit down and author content, we would be able to drop them the workflow and get them going. So we have all that in place. So we're basically ready for people to start saying, great, I'd like to work on the metrics chapter. Hey, I want to work on this self-care chapter. And what we're doing is we're writing an ASCII doc, which is a markup language. And part of the reason for ASCII, well, there's some, you know, some back-end reasons. We're trying to make simple, straightforward decisions about tooling and for the 2.0 release. And the goal there, and at that point in time, everything is up in the air. We can look again and see what worked and what didn't. And do we want to stay on a GitHub-based workflow? Do we want to move somewhere else? This is essentially, again, this is us practicing our own advice. You know, if as an open source project, don't get yourself spun around the axle, trying to get everything perfect right from the beginning. Sometimes you just need to get started with something that's good enough, and then keep iterating. And just make sure you write down what you don't think is good enough, so that you can not forget and fix it. And one of the important things for us using GitHub right now is that is where a lot of the people that we are interested in getting the first round of contributors for. There are way more contributors in places not than GitHub, but it's a clear, like, pretty large pool of people who are open source practitioners who are familiar with the pull request process. And honestly, it's almost easier to do than it would be to run like a Wikipedia. You know, even with the little edit button, we can't, you know, the ability to do the reviews and wrap keep the discussions around a piece of content wrapped with it is really nice in Git. Yeah, so exactly. So the discussions will stay with the content, and the idea is if you're familiar with how GitHub works or that kind of process works, we have an issue for every chapter. And so all the discussions about the chapter happen in that issue. They can be assigned to people. It moves through, do I have my picture? Yes, okay, it moves through a workflow. That is a pretty terrible picture. I can actually flip over to the browser to take a look at this in a moment. And I'll do that while I'm talking. And come back over here, little mouse. Go over to, I'm going to do this in front of me because then I'm not trying to do it over my shoulder while I'm talking to you all. Let me drag it into place. Okay, there we go. Okay. The point I'm doing, the reason I'm doing this is because unlike the slide, I can actually blow this up a little bit so you can see from out there. So we got over here. Here's a chapter on community fundamentals. It's an issue. If I click on it, it'll open up the details over here on the side. So it's a nice little swim lane based as an article. As a card comes, it's going to get moved from the to be assigned to the assigned through drafting, review, and editing phases. So essentially, we have set up a publishing workflow, just like you would with articles in a magazine or chapters in a book. One of our teammates, one of the contributors to the project, Brian Berenshausen, has worked on Red Hat's open organization books, and they used this workflow for deciding the outline of every one of the books in collaboration with the community of writers. And we're taking this a step further. We're not just doing the outline, we're doing all the content authoring in here as well, because it's an environment that's comfortable for the contributor base that we want. Let's see, can I just tip over? Yes, okay. Yeah, so the nice thing about that is when a piece of content gets all the way to the end and it's actually merged into an editor will do the final merging, which I'm going to do. It'll actually it'll close the issue, and it does all kinds of nice little project management stuff to make our lives easier, particularly when we're dealing with, I haven't done the count, but we've probably got 24 or 30 different chapters that we're looking at being possibly right now just for the 2.0 version. And maybe 1 or 2 authors per chapter, and just a lot of stuff to move through. So in terms of collaboration, we're trying to keep it simple and focused and not all over the place. We do not have we don't have a chat channel yet. We haven't decided where direction, and we've been using our team Google Chat for now, but we obviously need to break out beyond that. But the key is, asynchronous communication. So most of our meta discussions are happening on the forum mailing list, which is at list.theopensourceway.org. And the list has a web interface or email interface, depending on what you prefer to interact with it. And that's just the meta discussions. That's a place to talk about which chapters we might want, or will a series of chapters make the cut, like that kind of thing, from a bigger perspective and bigger vision discussions. But like I said before, the discussions around each individual chapter is going to happen within the issue, and within commit comments, so it all stays with that chunk of content. And we're also we've been running open weekly video sessions where our team just has a stand-up, and we carved out a section, a half-hour time that we're all there, and we're going to get on video and make it open, and just started doing it. It's imperfect so far, but the idea is anybody will be able to join or watch the live stream, and it's recorded, and it's another place for us to be able to not just be transparent, but to show the process by which everything is happening, which we know is key to attracting contributors. So in terms of who is doing what right now, there's me, I'm Karsten, and I'm the project lead, and I'll talk about what that means in a moment. Brian Proffitt is a lead editor. Some of you may be familiar with Brian from his work in tech journalism or as a community manager for, OpenSUSE. What else did he do? A bunch of things. And Brian's a very experienced writer and editor. And he knows how to say no when I have a hard time saying no. So one of the reasons I didn't want me to be the editor was because I didn't have to face that problem. And Brian's very good at that. So Sean McCants, Sean's here in the audience, so you want to wave your hand, is our lead writer, right here behind you. And the writer role is to work with writers while content's being authored before it goes into review. There's a number of different good reasons for that. Sometimes an author might just really need that comfortable back and forth without the sort of the way that an editor even when an editor's trying to collaborate with you, it kind of feels like they're telling you, it's like a teacher, you really should choose this answer, don't you think? It sort of feels like a little heavier-handed, where another writer is a collaborative opportunity, and we want to foster collaboration amongst everybody. So that's where that idea kind of came from, and Sean has a strong background in writing from documentation and from the GNOME project, so he's collaborated with a lot of people, and that's why we were looking for that. And then the editing team right now is the three of us, and anybody else who wants to come in. Mostly this is going to be, ideally the narrative flow and things like that will be primarily done by the time the editors are reviewing. The writers will have all found a way to make the stories flow and sound good together. So a lot of it will be, I think, copy editing and just having a broader picture of things. But if you're an editing nerd, it's a good chance to do things. And then the writing team right now, again, it's the four of us, Brian, Sean, and myself. But we've had a few other people. We're actually going to have to start adding names of folks who've contributed some stuff so far, and and keep going from there. But yeah, everybody's welcome to come in and contribute. And so basically, I pointed out with the workflow, but good little talk through exactly the details of what happens from, hey, I want to do something, to, hey, it's published. So the basic idea is the basic effect is to either go into the GitHub issue and put a note and say, I'd love to work on this, who else is interested? Assign it to me. Or you can come into the mailing list and discuss and say, I've seen these two chapters, I'm having some ideas around it. So that's a good way to start the conversation about what you want to do if it's not so sure. So those are the two places to really go and put a flag and say, I'd like to work on this. And then working on the content will happen in Git, in ASCII doc, collaborating with other writers and the lead writer, as I described, in that kind of back and forth to get something that really is, ready for review. When the writer feels that it is the content is ready, the one who's actually got their name on the byline on the chapter, that person makes a pull request. It's just a little bit of just kind of auditing the accountability, I guess. Just we want it to be really clear who said what and did what, and that kind of thing. I just feel like it's pretty. It's a best practice if you're able to do it. It's why we use version control, why we have git blame. And long as enough people come along to do the writing. So that's something we'll be discussing on the mailing list, because it's a nice meta discussion. I just wanted to touch upon project governance. I said before, that I described, I'm the project lead, we got the editors, we got this whole kind of thing of how we're going to sift to. Our vision is like, this is how we want to get the $2 book out and grow a community of collaborators around it. But also we advise that you don't have the same project leadership, and you keep succession planning in mind, and that a community should own its own governance, should decide how it wants to be ultimately. And we can't decide right now for a community of people who exist but haven't come together yet. So this is what the plan that we put forward is that for basically this whole thing covers through the book, right? So we figure it's going to take us about 6 months to get the book to the published state. That's what a little squiggle is. It's about 6 months. And during that time, I'm just going to take kind of like a strong leadership approach. Ultimately, I'll just make decisions as they need to happen just to keep things moving forward, and deferring to everybody else when we need it, and just following that process. And in that process, somewhere along the way, about halfway through, as the community is developing, we'll start to discuss what governance we actually want, how we want to run things going forward. And there's a lot of different models, a lot of different ideas. We'll have a chance to hash all those out on that meta discussion mailing list. And then we'll get it in place so we have it and it's ready to be adopted. And then once one of the celebratory points of the 2.0 releases, we're going to adopt a new governance. And I have no idea what it'll look like at that point. It may be some of the same people are still doing the same kinds of things, but it's going to be because it's been decided, and not because Daddy Shadow Man said this is the way the project is structured and go forth into the universe. Daddy Shadow Man is a Red Hat reference for those of you who don't know that one. Oh wow, look at that. Perfect, just under the half-hour mark. So let me bring it to the questions. I'll point really quick, that's the contributor mailing list, which is where all the discussions are happening, that meta discussions. Here's the full list link. List.theopensource.org will take you there basically. And all of these links are in the README as well. This whole presentation is in the GitHub repo. Try to do some circularity of stuff in there. And like I said, this actually, just let me pop over and show you. I'm sorry, I'm such a fan of the oh, come on, be nice to me. Right here. This is actually part of, so this is the HyperKitty interface for Mailman 3, and it gives you a full web form view into a mailing list. So half of my things I author coming to this interface and just clicking go and starting a thread and doing it because I don't want to go to my email. And other times I'm happy to do it from email. So this is a great place to ask questions. And of course you can find me in those places at iQuay.org, and Twitter is a good place to start conversations that we want to have in public that haven't moved into their space. Okay, so there you go. Any questions or things or questions disguised as comments or anything? Comments disguised as questions? Yeah.
So I guess what kind of inspired the reboot? Maybe I just did. I couldn't hear the people say, so sorry.
No, that's a good question. What inspired the reboot? I think there's a couple of things, and one of them was a little bit of an idea, not kind of ahead of its time, but the big vision was a little bit ahead of its time in that at the time, though, So I think that was part of it. So if we did, because what I really mean by that is, we would do something like this right now anyway if we didn't have a 1.0 to source from. We wouldn't be rebooting, we'd be starting from scratch. So that's the real answer, is because as our open source program office, so the medium answer on this stuff is that Red Hat's traditionally had all of its smarts about how to do open source communities at the edges. You trusted the developers in the projects to know what to do. Sometimes that worked well, sometimes that didn't work well. Projects that had more importance, or higher strategic value to the company, like Fedora, we would have more people in there doing community management functions, but a lot of the expertise really was at the edges. So it was only about 8 years ago, actually this January, that the open source program office was formed under a slightly different name. And that was the first time we had a centralized group of people who cared about making our projects wildly successful. And every year since then, I have gone to my management and said, is this the year that we're ready to restart the book again? Because again, it's kind of one of those blindingly obvious, like we're always we're answering the same questions, we're going to do the same things. And for me, it was just basically having patience to wait until everyone said, yeah, we are really ready to, we have so much knowledge going on, so many things, and we're going through constantly to grab things and point to people, and it doesn't make sense for us to have it in a little walled garden. And so we want to kind of, kind of reboot this. And so having kept it alive and the idea of it alive along the way really did help, though, because I think if we didn't do that, I think we would be starting a leg farther down for sure. So, yeah. And yeah, I don't think I answered that much detail when you weren't here, so you didn't miss that. Anything else? Okay, cool. And that was my thanks. That's me. Everything's CC by SA. There's my link to this thing down below. That's me, community.redhat.com. And I think that was it, right? Oh, no, I went down. Boop. Red Hat, thank you. Thank you from Red Hat, but that's it. Okay, thanks, everybody.
Hello, check. Yeah, that sounds a little bit better. No more of that crazy interference that we were seeing just a second ago. I'm good, unless you think the sound quality is not great in the room, but it sounds okay to me up here. It was this handheld was causing all sorts of feedback in the system, so I just used the other microphone. And I realize I just turned off my phone, so I can't actually wait and see what time it is. So I'm going to wait another minute or two because I can see that we're just a little bit early. But again, I'm chatting with you all and saying hello. I realize I'm now mic'd up, so I probably shouldn't insult anybody in the greater world outside of this room because, you know, that would look bad. Yeah. So how many of you are here because you mentor people? Wow, that's a lot of you. Great. How many of you are here out of general interest? Okay. How many of you are here to throw tomatoes at me in the middle of my speech? Okay, great. Wow, that's like the entire room. Okay, so now I need to know, are you more interested in throwing tomatoes at me or more interested in learning about mentorship? No response. I'm going to be coated in tomato sauce when I live here. Well, maybe you'll learn a lot about mentorship by throwing tomatoes at me and seeing how well I dodge them. I don't know. But yeah, it looks like it's about 6 o'clock, so I don't see anybody else rushing in the door. I'm going to go ahead and start my talk. So, hello everyone, welcome to my session on mentorship. I'm going to teach you a little bit about mentorship through my experience at San Marino High School Girls Who Code. So, the whole point of this talk is to teach us all how to be better mentors. I'm not here to stand up in front of you and say, I'm the best mentor in the world, you should come to me and learn everything I know. It's more of working experience and tricks of the trade, because I don't admit to be the best. I don't say that I'm the best mentor in the world, but I have learned a few things in doing this, and so I want to encourage you all with what I've learned. So, a little bit about me. I'm Michael Starch. I'm an embedded systems engineer here in Pasadena. I actually work up the hill at NASA's Jet Propulsion Laboratory. I've been mentoring at San Marino High School for about 4 years, and I'm best at teaching computers and basic circuitry. So, that's also me many years ago, but you know, you can confirm that I'm in the right room and you're getting the person you expect to talk to you. A little bit about Girls Who Code. Girls Who Code is a nationwide organization whose purpose is to encourage women to study coding and combat the gender balance in the technology sphere. Our club at San Marino High School meets just about weekly during the school year. We are open to all students, but we focus on teaching women. It's entirely voluntary, so students show up on their own will, and there are usually about 3 mentors to 20 students. Also important, I don't speak on behalf of the national organization. I am just a mentor at one of their clubs. So, the things I say here don't really reflect what's going on at the nation level, but what happens at our individual club. Because through this individual experience, we will learn and grow as mentors. And again, I really like questions, so if something comes up that you want to ask about or discuss, shoot up your hand and we'll go ahead and talk about it. Today's talk, we're going to talk a little bit about the coding club that I mentor at San Marino High School. We're going to talk a little bit about some of the methods we use to encourage passion, a few of the methods we use to compensate for the different skill levels of our students, and some methods in general to encourage women and, in fact, all students. And then I have some general advice, and down there at the bottom, my favorite thing in the world is questions. One of the first things that my students learn about me as a mentor, I like questions. We'll get into that in a little bit, but if you have questions here, now's the time. You've got me. Yes, go ahead.
So I seem to recall at this club you offered a bribe or reward for stumping you with questions. Does that apply here?
No. The only reason that I wouldn't have a question bounty here, and we'll talk a little bit about what a question bounty is later, is that I have no way to pay off such bounty if you do stump me, because the rule is I get a week, and I won't see any of you in a week. So you'll just have to try to stump me anyway for the fun of it. Some of the challenges in our club at San Marino High School. We have a lot of absences. There are a lot of students that come to our San Marino High School Girls Who Code Club who just can't make it every week. Either they've got studying to do, or sports to do, or some family travel, and they just aren't able to make it there every week. We also have a huge variation in skill levels, as should be expected at a high school. We have some students who start out as freshmen, we have some students who start out as seniors, and we have some students that have been with us for 4 years and are now seniors and have a good idea of what the club is about and what we're doing. And then our biggest challenge at the San Marino High School Girls Who Code Club is quiet students. We have a lot of students who are somewhat shy. They don't like to make a lot of attention. They're very good during the normal school day where they're supposed to be learning and letting the lesson proceed, but that makes it very difficult for me because I like questions, and when nobody raises their hands, I get no questions. But the biggest challenge we have at San Marino High School, and I think in general in terms of mentoring students, is a lot of students just believe that coding is too difficult for them to learn. Maybe they've seen a little bit of code, maybe they have some general idea of what technology is, and they think to themselves, I can't do this. This is too difficult for me. Look, it's not English, there are semicolons, right? That kind of mindset is what we're fighting every day. And we'll talk a little bit about how we combat that mindset, because we know as mentors that coding is not too difficult for us. Everyone in this room can code. You can see, I'm here, you look at my PowerPoint presentation, you see, it's kind of sloppy and put together ad hoc. Yeah, I code professionally. If someone who makes this PowerPoint can code, you can code too. But our students don't internalize that. So, moving on to a little bit about our club. The first year we were in business, we taught the canned lessons from Girls Who Code, so that was Scratch and Khan Academy. Now that first year when we were teaching Scratch and Khan Academy, the club didn't go so well. We had a lot of struggling students. And I'm not trying to say anything bad about Scratch or Khan Academy, but it was the way we were approaching the club itself. So the thing about Scratch and Khan Academy is they're canned lessons that are on a website. Great for individuals to learn from, great for large classes that want to walk through a canned material, but when you're in an after-school club with students who come there just on their free will, and you have mentors who are trying to teach this material that they didn't create themselves, there's a big disconnect. You have these mentors who are kind of a little bit unfamiliar with the material themselves, and the students who are brand new to this all, and we're all there voluntarily, and we're kind of wandering around in a circle saying, what do we do? So in some situations where you're mentoring students, this kind of canned lesson works well, but when you're really hoping to encourage students to come back week after week and there's nothing holding them except, faith in their mentors that they'll learn something, these lessons kind of start to suffer a little bit unless you engage in them. So the next year, we tried to engage a little bit more, and we came up with some mentor-driven lectures and projects. This is one of our projects that we started off with quite early on. It's a maze program, and we said we're going to teach them how to program JavaScript by filling in this window here and trying to solve the maze. And of course, you have a bird's eye view there to make the navigation a little bit easier. Unfortunately, the lecture format and these big projects made it very difficult for our students to follow what we were doing, because suddenly we went from, okay, here's some canned lessons that walk you through how to code. Now they're tossed into the deep end and expected to just learn how to code based on the lesson itself, and our mentors were still getting used to things. It's only the second year, and we really only teach once a week. So it's all a new experience, and the students found, one, the lectures quite boring, and two, the material was a little bit difficult. Now, on the lectures being boring, well, it's after school on a Friday. They've been in class all week, and they're wondering to themselves, wait, why am I coming to yet another class with yet another teacher speaking at us as if we're in a presentation, right? That's not what they want to experience on Friday afternoons. They want to go hang out with their friends on Friday afternoons or go to the football game. So we have to compete with that and try to get away from this boring lecture format that they're stuck in all week. Year 3. Yes, go ahead.
Who are your mentors? Like, you say there's 3 mentors.
Good question. So I will step back a little bit. I am one of the mentors. I come most weeks. Down here in the front row, we have Lan Dang. She's another one of our mentors. And we have two other mentors from the general tech sphere. Some of you may know Carlos Meza. He gave a talk earlier today on Python. I don't see him in the room, despite the fact that he promised to come heckle me. And then we have a fourth gentleman named Nick who works for Walmart. So generally
You're missing one more.
I am missing one more, and there's a reason for that, and we'll get into that later. I don't want to tip my hand entirely, otherwise the second half of the talk is immensely boring. So, those are our four professional mentors who work in the tech sphere. Thank you for that question, and are there any others? No? Okay, great. So, third year. We decided, okay, what's all the hot rage a few years ago? It's phone apps, right? All the students have their iPhones and their Androids. Let's go ahead and build a phone app. So we jumped into some apps based on Android Studio, and what we found right away with Android Studio is, well, as you can see, it can be quite complicated. So the phone app actually went pretty well, but the complexity of building a phone app with all of the specific XML that has to be written and the JavaScript or Java that you have to write means the lessons themselves were small and didn't have a lot of depth because we were trying to compete with this professional interface. So that was another thing that we tried and kind of went okay. Fourth year we went to a style of standalone lesson. This was primarily done to combat the students who were absent every other week. If you have a standalone lesson every week that is self-contained, the students that show up can learn, and next week if you get a random assortment of students, they can also learn. That project arc that we showed you with the Android Studio really started to fall apart when students missed half the lessons, because then most of the class didn't know what they were doing and couldn't build on the foundation of knowledge that we tried to establish. So we built things like this. This is one of our famous hacking lessons where they try to bust into this web page and learn a little bit about, computer security, breaking stuff, and most importantly with this web page, social engineering. The goal here was to try to guess what the username and password was by just looking at this web page, which is, somebody's blog. And in fact, I believe the password is down there at the bottom. So that's what we've done for the first 4 years of our lessons at Girls Who Code. And we're going to talk a little bit more about that. But before we get too far, I want to talk about what works and what doesn't work. Because the rest of this talk is what we can do as mentors to improve. So that was a quick crash course of everything we've done so that you have a little bit of context about where I'm coming from. But the rest of the talk is how you can be a better mentor. And for those of you who don't think you're a mentor because maybe you're not directly mentoring somebody, parents are mentors. Fellow students are mentors. People at SCaLE are mentors. Carlos in the front row is a mentor. So, for those of you who think I don't have anything to learn here, you're absolutely incorrect. Everybody can learn something from this presentation, and I've tried to phrase it in a way that all sorts of people can learn. So, what worked? Well, paper circuits was a good lesson. Yes, go ahead.
All right, quick question. So, what kind of hardware did you have for the students to work with? Did you have a computer lab, or were they bringing their own, or was it all done up on a screen?
Okay, so the question for those of you remotely is what kind of hardware or what kind of tools did we have? So there is a computer lab at San Marino High School, and for some of these projects, like the Android project, we did use the computer lab. For the lessons in the room that we'll get into more, we brought our own equipment, some Raspberry Pis and some old monitors that I have stashed in my e-waste pile. So it was really kind of ad hoc, but what's important is the lesson and not so much the hardware that it was built on. So our successful lessons really came down to paper circuits, which is where you construct a circuit out of copper, tape, and LEDs. This is a way to learn the basic circuit design and basic understanding of electronics. The other lesson that worked well is pseudocoding. This is a riot every year, and we'll talk a little bit about that more. Our biggest lesson in terms of people that come to our class is hacking, lockpicking, and security. So this is where we just teach them how to be, evil black hat hackers, and then give them a quick bite about, the legality of doing these things and how they've been given permission to try to destroy all of my equipment and computers. And then, of course, sounds and music really connects with a lot of the students, especially those students who are musical. And then what we found that does not work is lectures do not work. We're after school program on Fridays, as I've already said. Lectures just fall flat because the students have been in that format all week. They're bored, they're tired, and they want to do something fun, usually trying to heckle me. Complex instructions don't work. If you have a class of varied students who have a lot of different skills, if you give them super complex instructions, it just falls flat. They get confused, they get lost, and then pretty soon the entire class is talking on their phone, which is okay, but it means you as a mentor need to find a different way to approach those students. And then we've always struggled with small classes. If we have a small class, it's very difficult for us as mentors because we'll get into some of the techniques to encourage students later, but those students grow together, and if you only have 2 students who show up, it's very hard to get them to encourage one another. So, what can we do as mentors, given that we have small classes, absent students, and all of these difficulties that we've come up with? Well, the first thing I want to talk about is passion. We need to inspire passion in our students. This is one of the most important things we can do for students. They're in high school. They're going to go off to college or some other thing after high school, and they may not even join the tech field. But what we want to leave our students with is a lasting understanding that, 1, technology is fun. That's why we're all involved. And 2, you can do this. So, how do we inspire that passion? How do we release them onto the colleges so that they can go and be the best students they can be? Well, the first thing we need to do is make lessons approachable. That means we're going to start with brief introductions, we're going to get rid of all of that expert knowledge that is out there, and we're going to put success first. We need to make these lessons approachable because if the students come in and just see that giant Android studio with all this XML, or heaven forbid, C++ code, they panic. They think, this is impossible, I can't do this, and they shut down right away. Remember, they're tired. It's the end of the day on Friday, much like it feels right now. I want to sleep. So we need to get around that by giving them something quickly that they can succeed at. When they have that success moment, they are immediately pulled into our industry and know that they can succeed here. This introduces one of our best examples of a lesson, which is pseudocoding. Pseudocoding is one of my favorite lessons every year because all we do is say, here's a problem, go solve it on the whiteboard. Do they know how to code? No. Do they know what coding is? No. What do we teach them beforehand? We teach them a variable stores information, a function is a reusable unit of code, and code executes from the top to the bottom. Then we say, go solve the problem. And then we, as mentors, just walk around and watch them solve. And every year, it is the loudest, most engaging lesson we have because we've just shown them you can solve a problem just like I do as a professional coder without knowing anything about code except problem solving. And in the end, all code is a codified way of problem solving, right? So the syntax we know as coders isn't really that important because it will change next year. As I was discussing earlier, I used to write in Fortran, now I write in C++, and all of you out there are looking at me like, why don't you use Python? Syntax doesn't matter. What's important is your ability to think through problems. And pseudocoding is that. And here's our example from this year's pseudocoding lesson where you see a bunch of scrawled whiteboard notes and some input from our mentors. The students stay at this lesson until the bell rings at the end of the day, like 5 o'clock, well after they should have gone home on a Friday, and they still want to talk about those problems because right away they see we can engage in code. That's why it's a good lesson. The next thing we need to do as mentors is break out of that mold. Every day they come into school and they say, well, you have to learn calculus. Well, you have to go learn science. Well, it's noon now, so you have 15 minutes to go to lunch. Nobody's going to teach them anything that is outside the box. That's not what schools do. And I'm not trying to throw our nation's education system under the bus. They have to learn that stuff. It's kind of important. But nobody's going to teach them how to break into computers. Nobody's going to teach them how to do nefarious things or be evil. And yet, they're expected to just kind of understand out-of-the-box thinking. So here, this brings in our next example of a lesson, hacking. This is the second favorite lesson I have, and you'll quickly notice that every lesson I talk about here in this presentation is my favorite, and this lesson is hacking. Every year, we set up a lab in our classroom of computers much like this and say, here's a quick walkthrough, figure out how to break into this thing and do something nefarious or evil. In this case, this computer over here was supposed to be somebody's office. So as you can see, there's a nice monitor with a login screen and a whole bunch of photos from this person's life sitting there. The students were told, figure out how to break in, go. And then they just started, digging around, looking in the office, opening up notes, finding printed emails, and eventually they get to the point of finding a phone number. And that phone number actually linked to a voice actor I had hired so that they could call that person up and try to steal their password over the phone. This is exactly what social engineers do at DEF CON. Probably better than my lesson here because this was for high schoolers. But they engaged. They were on the telephone, they were digging through the papers, and eventually they broke into that computer. That's not something that they're going to be taught during their normal lectures. They're not going to walk into math one day and be told, hey, Go hack this computer. Go figure out a way to solve this problem with all of the restraints off. And it was awesome. They actually called up this person. One student decided to try to hold that person's dog hostage to get the password. You all laugh, but that student is engaged and is now one of our most promising leaders for next year, who has recruited 20 students for the club. It is amazing. And some of the mentors snickering in the front row know exactly who that student is. But my point is very simple. We taught them something that nobody else would teach them. They engaged. And they also learned life lessons, like if somebody calls you up on the phone, they may be trying to steal your password and not really your bank. So these kind of lessons, one, teach at all levels, and two, really engage those students, and it's all about that passion. Now, the biggest trouble with these hacking lessons that I run into every year is I'm just running out of ideas. I've come up with so many of these hacking lessons, and they just cut through them like butter. And now I'm running out of ideas. So if you have ideas, that's great. Also connect with their other passions. Yes, go ahead.
Did you have pushback from the school administration because the topic was hacking?
No, I have had nothing but support from my school's administration, and really what that comes down to is the teacher who is the overseer of our club, also the calculus teacher, hence why I made that comment about calculus earlier, really works hard to make sure the school knows the importance of what we're doing and really fights on our behalf. It also helps that when we're teaching hacking, it's all legal. Because there is another field of hacking called white hat hacking, where all those security researchers out in the room go and make lots of money doing this. So it is a professional trade. We phrase it as evil hacking because that brings in students, and then we right away before we start the lesson say, remember, you can only do this on computers you've had permission for, or it's a very, very big crime. So we start off with, the morality, and then we go right into the lesson because it's the same skills. So I've yet to have pushback from the school administration, and that really is due to the teacher that we have overseeing the club and working with the administration to make sure they understand the importance of what we're doing. Does that answer your question?
Yes.
Fantastic. So, the next way to inspire passion in our students is to just connect with the other things that they like doing. Every student you have has some sort of passion, just like we all have hobbies. My hobby happens to be embedded electronics, so I do it at work and at home. But most students come in and they say, well, I like music. I've been taking music lessons since I was a wee kid. Or I like art. Let me do art. And then they come to our technology class and say, oh, this looks like science. This might not be for me. Until they come to the lesson where we do speakers. Speakers allow us to teach our microcontrollers to sing. And this lesson gets our students up out of their seat, and they're looking up all sorts of sheet music to tell this tiny little Arduino that has no memory how to sing a 5-second song. It's the worst song in the entire world because 8-bit audio, really, really crappy output. but the students engage. Why? Because we've connected the dots to something that they really enjoy, which is music. So if you can take your project and connect it to their other passions, find a way to link it to something else that they love, they'll realize technology is everywhere, and that technology they can get good at without dropping the things they really love on the floor. This is the exact kind of mindset that you need for something like a startup or something like a research position where you want to love something but you need technology to get there. And we teach that by doing exactly that. We allow our students to love music, and then we teach them how technology enables music by playing it on a crappy microcontroller. But in the end, they'll end up in industry where they're building soundboards or building the next round of AI-inspired computer composing. So, when you connect with their passions, you bring those students in and they learn about technology and see that the technology sphere really isn't about just being technologists. It's about being people in this world who use technology to solve problems. So, the next big problem we have to solve, now that we have super passionate, motivated students, is how do we deal with students, right? They're by default learners, so they don't come in with a set amount of knowledge. They're all at different skill levels because high school has a set number of students, right? 4 years. So you have 4 years of different skill levels, and some students joined the club this year, and some students joined 4 years ago. So we need to combat that, so once we start teaching them, we can cut through all of these different skill levels and land somewhere where everybody walks away with useful knowledge, even if it's not the same knowledge. So the first thing we do at our club is focus on exploration. We've seen that already. That hacking lesson, we basically said, go figure it out, right? We let them explore, and there were multiple answers that could get them through that login screen. Why? Because if we wanted them to learn one very specific thing, they would be hung up on, do I have the knowledge to do that? But if there are multiple paths to success, students will find their own way. Also, they make connections to their own life when they're left to freely explore. And my favorite part, questions. When they're exploring, questions come up organically. So it's not just, hey, think of a question, ask me something. It's, you're exploring through a problem and you run into a problem and your brain goes, I wonder what that is. And then they just kind of say it before they know they're asking a question, and suddenly that quiet student is enabled to learn. We had this a few weeks ago. One of our students was just sitting there and realized, I don't know what binary is, what is binary? And we had this awesome discussion on the whiteboard about how binary, ands, ors, and Boolean logic work. And by the end, she understood how to do Boolean logic, and she had never been exposed to it before. It was great. Why? Because we just let her explore through a problem set until she found something she did not understand, and before she even realized that she was interacting with a mentor, she had asked a question and had learned something. It was amazing. And then, of course, exploration is just fun. Most of us are in the technology sphere because we like to tinker. Maybe not, but I love to tinker, and without that fun of exploring, we all get bored sometimes. So a great lesson that helps us explore is paper circuits. Our paper circuits, as we talked about, were copper traces, LEDs, and a battery. That allows you to basically form a flashlight on a note card, and it's cheap enough that they can all take them home. The cool thing about paper circuits, however, is there are lots of paths to success. You can look at a paper circuit and say, here's a circuit. You can add a switch. You can add a parallel LED, a serial LED, and pretty soon you're getting questions like, if I string 3 LEDs in a row, excuse me, they don't light up. Why don't they light up if I string 3 LEDs in a row? Well, it's because LEDs have a voltage drop and you need more batteries. Hey, that's a question. They just learned something about LEDs. Why does it work when I put them in parallel? And then you can go into Kirchhoff's laws. And I'm glossing over some of the technical stuff, thank you. I will get to that in just a moment. But the fact of the matter is, they've been able to learn. They've been able to explore the problem and find something that interests them. And then they take it to the next level and put me to shame when they start folding the paper circuits into origami, and I look at it and say, I could put a circuit on that, but I can't fold origami. And then they realize, myself as a mentor, he's not, omnipotent or super intelligent. He has his field of expertise, they have theirs, but we can learn from each other. And so I learned some basic origami, and they learned circuits. The next thing to remember when you want to deal with varying skill levels is to focus on those success moments. It doesn't matter how much skill you have, a success moment is still a success and it will be memorable. How many of you remember, if you're coders, your Hello World program, that very first one that you wrote in BASIC on, Quick Basic? Everybody's hand went up. Everybody remembers their first program. You all are remembering when you were very new to this field. Now, a few years ago at SCaLE, I managed to hack into the kernel and get one of our video processors to be more efficient. I did a success dance. We in the AV team will remember that forever. Why? Because it was a success moment. Success moments, if they come with dances or just, silent celebration as it says Hello World, are memorable. If you doubt me, you all remembered your first Hello World program. You remember the language it was on, the computer it was on, because it sticks in there. And this sense of accomplishment makes you confident, right? Once you were able to see Hello World pop up on the screen, you probably said, oh, I can do this, right? Because you succeeded at something. That's very important. And we've shown that the skill level doesn't really matter. You've succeeded at something. It will be memorable. And then my favorite part about success moments is that it demystifies technology, right? The moment you succeed at doing something in the technology sphere, all this technology just seems approachable. Oh, yeah, it's just code. It might be a few more lines or a few 100,000 more lines, but all it is code, and suddenly it's not scary anymore. So, one of our big success moments from last year was our moving robots. We had built these robots that had wheels and stepper motors and a little Arduino, and I wrote just enough motor driver code that they could start plugging in move forward, move back. And this class went ecstatic. The moment those wheels turned and the robot drove off the desk and hung on its power cord, they were engaged for an entire hour, to the point where we had to chase them out of the room. Because they had seen that from just a bit of code, they're able to create motion. All the things that they've dealt with in their lives so far is moving cars, jet planes, motorbikes, and they think, I could never build that, until we did in one lesson, and they were hooked. Yes, go ahead. You had a question.
Was it like old logo or turtle with actual robots?
So this was just an Arduino program. It wasn't anything specific. It wasn't a set bit of technology. It was run stepper motor forward for 100 milliseconds, and then ask them what the next command was. It was super basic, and just a couple of lines from an Arduino library. The biggest complexity in the code is I bought the wrong motors and bought stepper motors, which I learned were harder to control than normal DC motors. But apart from that, the code was, 30 lines of code, and most of it was comments, and the students just copy and pasted. But does it matter? Not really, because they were able to get the robots moving. And that's a picture of the actual class. You can see we had a Raspberry Pi set up there as our computer, and the robot there, which would promptly drive off the desk, unless they got it to spin. And then we got to teach them a little bit about power cord management and safety with the power tether that we had coming off the back there. It was a success moment. I will remember it forever, and so will they. And then the last thing I like to do for different skill levels is to just be pedantic about encouraging questions. You've seen in the middle of a talk at SCaLE, I have already encouraged you to ask questions and answered them in the middle of my talk. Why? Because I think questions are important. Even in the middle of a presentation with remote viewers, we need to have questions. Because if we don't have questions, we don't know where each other is and we can't learn. So, love questions. As mentors, love your questions. They allow self-learning and they betray confusion. If somebody asks me a question that doesn't make sense, I know you're confused. So, if you come up to me and ask a question that you think is great, and I say, I don't understand that, that means I know where you are. You are confused. And it doesn't matter then. I can teach to you because I understand where you are. So I'm not trying to insult any of my students who may be listening on the remote feed. Do ask questions, because even if you're confused, that is a point where your mentor can use to expand your learning by understanding where you are. And so every year I put out a question bounty. That question bounty is basically, if you can come up with a question in STEM that will stump me, and I can't get you an answer by the next class session, I will buy the class food. So far, these students have been unable to cash in on this bounty because I'm very good at looking up information that I don't know in preparation for the next class, but this student here that you see pictured will stump me eventually. They have been hitting me with genetic engineering questions, which is a little bit outside my league. Fortunately, the last set they did not phrase as questions, so I've been able to skate through on a technicality this time. But next time they will phrase it as a question, and then I'm going to have to go learn advanced biology. So, kind of the heart of this talk and the heart of Girls Who Code is how do we encourage women? So that's one of the most important parts about our club at San Marino High School, because most of our students are women and most of our students come in from a perspective of, well, this tech field is kind of, you know, not fully balanced, and it's very daunting to come in. So, grant a voice. This works for all students, but I find this especially important for encouraging our quieter students. Give them a voice. I walked up here and I started talking, and I said, please ask questions. How many of you really felt like you could ask questions? A couple of you. I don't really think the entire audience is, because otherwise I'd just be answering questions the whole time. Granting a voice is where you say, student, please say your name and something that is special about you, right? My name is Michael, and I like to bake pumpkin pie, right? Well, now they've been invited to speak, so that natural weight of being in a social situation is lifted because they've been given a voice, and now they've been invited to open their mouth and speak. And so now those questions come out. So we start the year every year with an icebreaker specifically designed to say, hey, open up, say something important about you, ask your questions, and have that voice so you feel confident asking questions or speaking up in the middle of class. I'm no longer above you. I'm no longer a presenter on stage controlling the conversation, but it's a conversation between everybody in the room where you can speak. And this creates an opportunity for our students to talk. Yes, go ahead.
At some point appropriate, I would love you to describe that.
Oh, this picture? Yeah, so I was just about to get to that. So this picture here is our icebreaker this year. We took a bunch of pieces of paper that had if statements, variables, and I think it was just, and some basic operations like concatenation and pluses and all of that, and we put it on the floor and we showed them how a computer works. It's a basic procedural state machine on the floor. So they walk down the floor, if they hit an if statement, they look at it, evaluate the if statement, and branch back to another point in the program or continuing forward. So we had all of the students speaking to one another, running through this floor computer and making a lot of noise. But most importantly, we had a student at the end who was the computer memory, who was tabulating things on a whiteboard with a dry erase marker. This meant they had to talk to one another. They couldn't just make up the decision in their head of what the computer should do. They were granted a voice by saying, well, you have to tell that person what to do. That really got the class talking, and that meant the students feel comfortable with one another, they feel comfortable with their mentors, and they're able to ask questions because they've been granted a voice. Any other questions here? The next thing that I think is very important is creating a focused environment. This is very important because in the tech sphere, one of the biggest things that makes it hard to feel a part of the tech sphere is those people out there who know everything. And nowadays, I'm probably guilty of knowing, or at least appearing like I know everything. But when I first started out, especially I work at JPL, it was terrifying. There's all these people around me who have PhDs and like build rockets and stuff, and I'm a lowly computer operator who knows where the space bar is and about nothing else. That makes it really hard to grow, because when you're terrified or feel like you're not getting something because you don't know as much as that other person, even though they might be in your same grade, that makes it very hard for you to feel confident to speak out. So, understand that know-it-all students undermine growth. And that huge amount of confidence that comes with knowing it all really makes other people struggle. So how do you deal with this? Because the last thing you want to do is tell a smart student, well, stop being smart, right? But kind of you also want to say that because smart students make everybody else kind of feel dumb. I've felt that way. So how do you deal with it? Well, one, pair programming works really well. I know pair programming is kind of old, you know, Windows XP, that kind of era, but sitting with somebody and having one person type and one person dictate what should be typed, and then swapping after about 15 minutes means that no one person can know it all because there are defined roles. One person has to think through the problem and the other person has to operate the computer and actually type in for the problem. So they're forced to communicate and they're forced to swap roles so that a person who needs a little bit more time to think is given that time while the other person is operating the keyboard. This enables students to learn without, cutting the tall daisies down, but it allows them to learn together because you've separated the roles. And that's really what our club is about, is making sure that when we get students in a group and there might be that student who just can solve that problem really quickly, we make sure that the roles are forced to change so that students can continue to learn and have a chance to think through the problem. A great example of this is our pseudocoding lesson every year. Every year we do that pseudocoding lesson, we saw it on the board earlier, we change who has the marker. We say only one person is allowed to have the marker and it will rotate. So if one person is up there sketching the entire pseudocoding problem and they've designed the entire app and then, the clock ticked, now another student who wasn't saying very much because they're a little less confident and a little more quiet, they're now encouraged to speak and they come up with the greatest ideas. Just last week we did a pseudocoding lesson where one of our more quiet students said, hey, can we put AI on this app in order to cause the robot dog we're trying to control to think through what it's going to talk to the human in response to a question? And I said, that's the most amazing idea, because now you've thought about, well, I've heard AI, and I know basically what it can do. How can we integrate it? And we had a great discussion about how, yes, it's very possible, but would take longer than we have in an after-school program to figure out. But they learned that their idea was possible. And all because we let a student who is typically pretty quiet guide the conversation in front of all of our other students who might be a little bit louder. And so by changing roles, we don't leave anybody out, we don't restrict knowledge, but we give a voice to other students. And then the last piece I like is encouraging inter-student learning. Now I see some chuckles. This was the approved photo from our last mentor who I have not introduced, which is a student from PCC. Local community college right by San Marino High School. She sent me this photo and said, please use this. So, I'm absolved of the photo choice here, but why did we invite a PC student into our club, and why did I wait till this point in the presentation to introduce her? Well, it's because students encourage one another. I can come in and I can say, I'm going to teach you everything you need to know about technology, and you look at me and say, you work at JPL, there's no way I can get to your level. But if I have a student who comes in and is literally 1 year further along in education than they are, that student can help, that student bridges the gap between my knowledge and theirs, and shows that there's a path forward. We now have this student who was in their shoes literally a year ago, can speak all the latest vocabulary like yeet and meme, right? And is able to take those students and help them grow. This mentor has really enabled our club to function more effectively because I don't really, until I met this person, I didn't know what yeet meant, and yet the students were saying it. I didn't understand how involved they are in technology until somebody said, well, yeah, they use iPads to look up things rather than their computers. And I start to feel kind of old, but she bridges the gap. Now they have a path forward and somebody to translate to me. Yes, please, go ahead.
So what does yeet mean?
So the question in the room is, what does yeet mean? And I'm sorry, I've now learned the vocabulary and use it all the time. It is the sound made when throwing things. But it's a verb, which makes absolutely no sense from an English perspective, but it's a great word anyway, because you say yeet, do something like this, and pretend you're throwing something. It's said as kind of in the context of being excited or happy. And you can have these students that you bring in who speak the lingo and know how to use the emojis on the phone, encourage the students, and continue to guide their education, and most importantly, be a role model because those students can see themselves It's not that far away. Yes, go ahead.
Can you actually use it, like actually use it?
Can I use the word yeet in a sentence? No, because it's usually used in a sentence on its own, yeet exclamation mark. But you can say something like, I yeeted all the way to the bank with my paycheck. And now I'm going to sound very old to all the Gen Zs listening on YouTube. So let's get off that subject, and maybe next year at SCaLE, I can give an entire talk on the usage of the word yeet. So, general advice for teaching students. This is where I come in and start saying what you should be doing as a mentor. And we get to my favorite activity in all of Girls Who Code. So, embrace you, the mentor. Passion is contagious. I'm a mentor. I go into that room, and if I'm teaching about something I really care about, the students cannot help but hang on my every word. This was shown just last Friday. Not last Friday, that was 2 days ago. A week ago Friday, I started talking at the end of lesson to answer some question they had about space, and pretty soon we were talking about Apollo 13 and why it failed. All of the technical reasons behind Apollo 13, and actually it was successful, but only because we were able to pull it out of disaster as, a country. So those students kind of grew up with that story, right? It's post-Apollo era, so they kind of know it. Yet they stayed till half an hour past the end of lesson, hanging on my every word as I talked through it, not because they deeply understood the technical issues of what we were going through, but because I was passionate. I was speaking like I am now, filled with energy, and talking about exactly what went wrong when the oxygen in the oxygen tank exploded and took the spacecraft out. And it all started with a discussion of, if you launch your spacecraft in the right orbit, it will automatically return home even if it's completely non-operational. Great way to launch your spacecraft to the moon. We'll talk about that later after the talk if you'd like to learn more. But the point is, those students wanted to hear what I had to say because I really enjoy saying it. Heck, I just brought it up in this talk. So, whatever makes you passionate, whatever makes you say, I like this technology field, bring it there. Because we all remember our favorite teachers in high school. They were the ones who got up on their desks and danced and did the little shindig and let us play with the radioactive sources from the physics lab because, hey, we had them, and they were passionate about what they do. They were the ones who encouraged the students by just being who they were. So, a question for you as mentors. And remember, everybody in this room is a mentor. What makes you unique? What makes you special? I work at JPL, and I'm super nerdy. So I come in and I say, I do space stuff, and I really like questions, and we're going to talk about everything. And those students engage with me because I just enjoy being there, even though I don't speak their lingo. What can you bring to the table? What makes you a mentor that will engage students by just enjoying what you do? That can help focus your lessons and bring students to the table. Invest in your lessons. Lessons take a lot of hard work. Again, I don't want to throw things like Scratch or Khan Academy under the table. They're fantastic programs, but if you're the mentor leading through those programs, study them. Understand what questions are being asked. Understand the deep technical context behind those questions so that when students ask you something, you can answer. Put forth that work and it will help. You will also learn too, which is a great thing because students are more easily talked to when you've just learned the material yourself. You can put yourself in their shoes by knowing where you struggled the day before. So a good question to ask here is, what can you learn? What do you want to learn? That's one of the reasons I started this question bounty to begin with, is I like learning. So I'm just like, ask me questions because I want to learn too. And that's why I'm so good at not paying out, because if they ask me a question that might stump me today, I will learn an answer very quickly. And so this is a good example over here. We had them exploring by building computers, like right up off the ground. Now, how did I invest in this? Well, I wanted to build a new computer. So rather than building it myself and just saying, look, take it apart and put it back together, I handed them the equipment and said, this is my new computer. Please assemble it, right? But by investing in it and saying, okay, I'm going to take the risk that they might destroy something, they got to build a working computer from scratch, boot it up. Well, that's one of the things I did when I was learning. When I was, well, in middle school, so maybe not this short, but I built a computer with a friend. And forever I was hooked because, hey, I built a computer, right? That fancy box that seems so magical, and I haven't learned how to program it yet, but I will someday. I built one. That's really cool. And so we can invest in our lessons. And then the next thing is, don't fear. And this is the greatest lesson we have ever done, and also the lesson that had me the most terrified, our lock-picking lesson. I taught the students how to pick locks. Now, for one of you who asked the question earlier, do you ever get pushback from the administration? Well, the answer is I haven't yet, but I thought I was going to get fired for this lesson, because I'm not just teaching them some ethereal white hat hacking thing. I'm literally teaching them how to unlock locks like the ones that protect all of the valuable resources at their school. This one had me terrified, but I bit my lip and said, we're going to teach it anyway. And this was another one of those lessons where the students just sat there and kept at it and kept at it and kept at it. Why? Because even though I was terrified, we were able to get through it, and they were able to do something that I didn't do until I was an adult. Like, really an adult, like with, a car and a job and an apartment, because nobody else would teach me. But they got taught in high school because I was willing to just say, you know what, I'm going to take that fear, bottle it up, and we're going to move forward with what should be an amazing lesson. And if you don't think that they were amazed, see that little box there? That box was filled with treasure, and by treasure I mean basically the food we'd give them if they won the food bounty was in that box. And we said, if you get in, you can steal all of the prizes you want. They opened up the box and then locked it again and picked the lock again. Opened it up, and not a single thing was taken out of that box, not a single piece of treasure went missing, because what they engaged with was, we get to break into something, right? I mean, these are students who get to unlock something and don't even go for the very obvious incentive that we put inside, because the learning is so engaging because it's out of the box. This one terrified me, but it helped our students grow. Remember, you as a mentor, you're invaluable. So if you're afraid, that's going to really make your students struggle. But you are not alone. There are a lot of mentors out there, so you don't have to be afraid of messing up or saying the wrong thing or teaching the wrong thing, because they will run into a lot of mentors. Your job is to be out there and just try, and eventually one of these mentors in their life will stick. And then don't fear failure. The times you fear failure as a technologist and as a mentor is where you can run into trouble. But you shouldn't fear that failure. You should just push forward and keep teaching, because that's how you get to things like teaching high schoolers to lockpick and watching them go, wow, I didn't know this was so possible. And we had one student who sat there and learned how to pick all of the locks, even the ones I can't pick, as a mentor. So our question for this slide is, what do you fear in terms of your mentorship, and how can you get around that fear? Do you fear not knowing the answer to a question they might ask? Well, make it a goal of theirs to ask a question that you can't answer and show that you're, one, not perfect, and two, that there's lots of learning to be done. Do you fear standing up and talking in front of people? Well, if you fear that, turn it into something that they can learn from. Show them that every year our students give a little presentation and they're terrified. Show them that you, their mentor, can be terrified too. Because this is how people grow. They don't grow by looking at their idols like all those super wonderful basketball players who make lots of money and then just magically become a basketball player. They grow by finding people closer to their level and engaging. So if you're afraid, turn that into something positive. So, conclusion. Things to take with you. Don't be afraid. You are their mentor. Go out there and shine. Do things that are crazy outside of the box, because that's where students engage. They get enough of in-the-box thinking. That's what school is for, and that helps them learn the things they must know to go out into the world. But we're going to teach them things that nobody else will teach them, and that gets them attached and passionate in our field. And last, be yourself. So rather than throw up another photo, I threw up the topic that I talk about most often at our club this year, which is my project at work. I love that project, and I love talking about it with my students. So that's what I bring to the table, and I'm not ashamed. And lastly, thank you for being mentors. Really, I want to thank you because I know that everyone in this room who's thinking about mentorship, who's engaging with my talk and saying, how can I mentor better? And I see some of you like taking notes and taking photos. Thank you. I know it's hard. I know sometimes it's terrifying, but even the littlest bit of mentorship helps people grow and makes our field better. So that's my talk. I'm happy to answer questions until somebody comes and tries to run me out of the room. Yes, go ahead.
This isn't a question, but this is a sign of appreciation from 3 of our students who attended SCaLE this year earlier this morning. They say that they look forward to Fridays at our club. They think that our club is the best possible thing. They're so happy that they learned about it.
Awesome! So I don't get a lot of feedback from students, but apparently a few of our students look forward to our club every week, and I do get the feedback of, well, students keep showing up. So are there questions about mentorship? I went briefly through what I know and places where I think you might improve, but you're all mentors too. What can you add? What would you like to know? Go ahead.
So you went through like, trials and errors, success and not. So were you kind of, the ideas that did work, were you kind of like reinventing the wheel, or were you researching things that people have done and kind of taking it and molding it your own, or were these just like out of the box ideas you had on your own?
So that's a great question. And the question for the remote feed, I try to repeat them, but I often forget, is, well, did you take what you've seen and researched to have worked in other clubs and other groups that are mentoring and modify it to be your own, or did you just start with something brand new and see what sticks against the wall? And honestly, I think that really comes down to the mentor. I'm not much one for researching what other people have done because I just like technology and I like exploring. So I try to think of ideas that would engage me and bring that to my students. And for the first couple of years, that was kind of some worked, some didn't work, but it resulted in some of our more popular lessons. I don't think there are a lot of mentors out there that would be teaching high schoolers lockpicking and building full-on office suites that they can hack through with our social engineering exercises. Some of that comes from my creativity, and some of that comes from I'm just willing to, put forth a ridiculous amount of work to make some of these lessons function. But I understand that other people like research and like to see what works well out there in the community. So if you are the kind of person who likes to read about things and adapt other ideas, by all means do so. My point earlier was not to discourage canned lessons or things that work from others, but to say engage with it on your own level and bring your own unique spin to it, because that's how your passion is driven into the lesson. Yes, please continue. So that's a good question. Most of my lessons end up on GitHub under my own personal account. So if you can, do a little bit of open source espionage and figure out who I am, Google search, you will find a lot of my stuff on GitHub. That hacking webpage that you saw is there. The code for a robot is there. The instructions in some of this stuff for that social engineering exercise are there. I don't make any claims that it's perfect because I'm not publishing lessons, but it is all available open source so that you all can take a look if you'd like. These slides should be available on the SCaLE feed. I have an older version of slides published currently, and I'm probably going to leave those there because there's a lot more text and description in those. So these were minimized so that it was easier to go through the presentation, but the other one is much more like an instruction guide. It has more in text and more explanatory material. So you can take a look at those if you'd like. Yes, go ahead.
So it's actually more of a comment, but I would say that as a mentor, he's not teaching in isolation, and so there is a lot of discussion happening with the club members themselves. That's actually, I think, part of the reason why we can engage, if you want to talk about how we involve the club members.
Sure. So we quite often have a, what do we call them, circle up your wagons with the president and the vice president of our club right after the lesson and talk about what they want to do and what works well and what doesn't work well. And we really struggled the first couple of years to understand what they were saying and really figure out what we were going to do to engage them, because there was a huge learning curve on my part to learn to be a better mentor, and on all of our mentors' parts because they're all brand new. But as time went on, we got better better at understanding where we are in relation to our students, and then we started bringing lessons to the table and figuring out how we can work with the students to move forward. So what a typical one of those round wagons looks like now is I walk up and say, all right, or Lan walks up and says, what do you want to learn next? And they spout off some idea. Oh, we want to do this. Usually it's we want 5 more hacking lessons, because hacking just sells to the student body really well, because you can say, you know, we're hacking at this club, and the students are like, wow. And then we talk through, what does that look like in terms of schedule? What does that look like in terms of what we're going to teach? This is how long it actually takes for a mentor to put together a lesson, so we really can't schedule this next week because I'm at SCaLE and there's no way I can produce a lesson in that time. And then they come back and say, well, we're not willing to have a 3-week lesson on this because we have spring break in 2 weeks and we don't want to leave for spring break and come back. So it's a lot of that discussion is now happening directly with the students, and that helps a lot, is engaging their leadership team. So in terms of our club organization, we have a teacher who's there on behalf of the school system to manage the club in terms of San Marino High School. We have professional mentors who are there to manage the learning in just being mentors, but then we have a full class organization underneath, president, vice president, treasurer, who are all members of our club who work through the actual organization of their club, and we've started making them do the decisions. You will tell us what lessons you want, and we'll suggest some things, but it's up to you to choose. And that also mentors them in leadership, which I didn't get into here, but we're also trying to teach our students to be leaders and, you know, owners of the tech sphere tomorrow. Yes, you had a question. Oh, go ahead.
Okay, fine. Do you have guest speakers, so let's say women in STEM or women in technology?
Yes, as a matter of fact, we do. So just today is Saturday. Yesterday, there was a panel at our Girls Who Code Club, organized by Lan here, who brought in a bunch of women in tech who were able to talk to the students, and I heard rumors that it went very well, but I've kind of had my head in the sand with the AV team that I work on here at SCaLE. So you could chat with Len after after this discussion and get a little bit more information. But we try to bring in these speakers to talk to the students, show a deeper path forward, or in this case, we try to get some very new employees and new women in tech to talk about like the college process. So we do try to bring in those speakers and have a few over the course of the year. I don't directly do that myself. I work a lot on the lessons, and Len here is very good about organizing some speakers, and also we do a tour of JPL every year and get our students to come there to see what it looks like to work at a technology organization. Yes, go ahead.
I wanted to make a comment that I hope you'll repeat on the remote record. Even this thing that we organized, we asked them, what do you want to do for International Women's Day? Do you want to have speakers? And when they agreed, we said, well, what kind of speakers? What are you interested in? And then when they agreed to that, then I said, this is how the panel will work. They're going to briefly introduce themselves, but all the questions are coming from you. They're not going to get up and give a talk. All the questions are coming from you, and we make them like think up all the questions, and I type them up and I give them to our speakers.
So for those of you on the remote feed, the answer was yes, we do engage our student leadership team and say, you've got to come up with this stuff. Do you want the speakers? So it's something we offer them every year, just like we offer them the JPL tour every year, but we don't force it down their throats. We don't say you must do this. It's their approval process. They say, yes, we want this, or no, we want that, and we get them to engage and tell us a little bit about what they want. So this year, one of their requirements for our Women in Tech panel that we had yesterday was to say, we want newer employees, newer women in tech, so that we can learn about the college process, because let's face it, I as a mentor really can't talk about college because that was longer ago than I'd like to admit. I saw a question over here, and I believe you still had a question, so I'm going to bounce over here.
I'm just curious, how the school and the team separated from the audit, like having team, the presentation to get competition product. Because we from high school, so I'm just really having learning for everybody. I'm not interested in teams. I think they are not really practical learning. So I'm just curious how the Marina High School get a club like this that is pure for learning.
Okay, so for those of you on the remote feed, the question was, well, how did San Marino High School pull off a club that isn't focused on competition, isn't focused on winning a specific thing, but is basically just another class, right? Focused on learning itself as opposed to this competition or this academic team or this, math decathlon or science Olympiad or the robotics competitions. How do we pull that off? And the answer really is, well, a few years ago, and I'm thinking it's more like 5 years ago now, we had a student who was at San Marino High School who said, we should have a club to do this, and went to the administration and said, hey, we want to do this, and went to a teacher and said, will you support this? And came to us mentors and said, hey, I know you through the local tech organizations. They'd involved themselves in things like SCaLE and said, we want you as mentors. And they put the pieces together and went through the administration to get that process done. Standard club, student body club organization. And then every year since, our existence of that club really depends on the students saying, we want to do this again, and doing the appropriate administrative things to get it done. So really it comes out of the drive for our students who say, we want to do this, we want to do this, we want to do this. And we had to have a tough conversation this year about next year where we said, look, the entire club is seniors except one person. Hey, one person, are you going to have this club next year? That means you have to recruit and find these students, because if you don't have anybody but yourself, you're not going to be able to convince the San Marino High School to let you have it. But once you have a group of students, they push through and have the school system say, yes, this is okay. And then we just needed a teacher who was willing to hang out with us after school and say, I'm going to let them be in our classroom, and I'm going to be the teacher face to this club. Does that answer your question? Did you have a comment on this or another question?
On that.
Yeah, go ahead.
That kind of leads right into this. As a mentor, there's someone who's not obviously in high school. Let's say you want to start something like that at the local school. What would be the process of the recommendation? Is it always going to be students first? So
the question for those of you on the feed is, well, what if I want to start something and I don't have students pushing for it? And the answer is, I'm not a great person to ask on that, because I was literally recruited by a student who said, we want you as a mentor, because they knew me through something else. So some general advice I can give is, don't be afraid to teach smaller groups of people for the current time. If you don't have a large group of people you want to talk to, mentor a few students that you know. If somebody asks for help, be willing to mentor them and walk them through that process, because that's what turned into our club. We had a student who came to me and said, I want to learn Python, and we started talking about some Python, and the next thing I know, they were like, well, I want you to mentor our Girls Who Code club. And I said, I don't know what Girls Who Code is, but it sounds fun. So, take those little opportunities and just, be willing to help people anywhere in your community, and eventually stuff like this will form. You can also encourage things by saying at local libraries and stuff, oh, I'd like to set up this, or oh, I'd like to set up that. But if you have that organic growth, it's a lot easier to get the number of people you need to do something like that without hoping that, if you build it, they will come, right? You've had a question for some time. So we have about 10 to 20 students most years. Our first year was more like 5 to 10, and this year we've had 20 and 4 and 20 again, so it's bouncing around a little bit as they struggle to recruit next year. But I believe some of the students who gave us positive feedback this year at SCaLE are actually hoping to come next year, so they're some of our new recruits. Is there a reason why we only have girls? So we actually have students who are male as well. It's Girls Who Code is the national organization, which we were created to be a local chapter of, but due to San Marino High School requirements, we can't limit it to just one gender, and nor would we want to. We just specifically encourage women to join and encourage the club to, move that message forward, but anybody who wants to come and learn is welcome. So we do absolutely nothing with a student who misses a class. We know that this is entirely voluntary, and we don't want our club to become a burden or another class that has lecture. So we've actually tried to work our lessons around, as I said, to avoid the problem of students missing class by doing shorter lessons, and we tend to now produce our teacher material so that if we have a follow-on lesson, they have the handbook to start with from the last lesson. Yeah. Do I have a budget? So I do believe we get some grants from local organizations, the school board, and we apply for grants from Girls Who Code, but we don't have a strict budget. We just say, all right, we have some club funds, we have a treasurer who manages those funds, and if we want something that doesn't fit into those funds, well, we either decide to donate or we go rooting through e-waste. So I have a lot of donated monitors that came from our local Linux user group here in San Gabriel Valley who were like, we don't need these anymore. And I said, great, I can put those to use. I try really hard to reuse the stuff I have to teach because I don't want budget to be a limiting factor. But there are grants you can apply for in various school districts and other national organizations if you need a budget. Does that answer your question? Yeah, go ahead.
They tend to be the students from the AP, science class, or automotive class, or they are totally from a variety of perspectives.
So
I'm just curious, the students who come, are they on usually on the fringe of learning technology, on the edge, they're on the fence, maybe they're not really very super inspired, or they're very motivated real students in free time.
So the question was, what are our students like? Are they the super motivated AP students, or are they kind of other students in the student body? And the answer is it runs the entire spectrum of students. We've had students in there who know a little bit about technology, have taken all the computer courses, have done the AP computer science, and really understand what they're doing. And we have students who don't know what technology is, but their good friend was the recruiter for the club and said, you should come. And in fact, we've grown all of those students, even the ones who don't really know technology, to the point where they know they can succeed at technology, even if that is not their thing. So San Marino High School tends to be one of those very high academic performers here in the San Gabriel Valley, so we have a lot of very motivated students, but it's a high school, it's a public high school, so there are students who aren't quite as academic, and we've had them in our club, and they love learning. So we try very hard to make sure it's approachable to all, open to all, and really an encouraging environment where everybody can learn. Yes, go ahead.
So I guess you kind of touched upon it for his question, but San Marino High School has a computer science program?
So San Marino, the question was, does computer science, is it taught at San Marino High School? And the answer is yes, they have a Java class and a few other classes, and some of our students have been through those courses, either joining the club or because they joined our club and said, I like this, I'm going to take the Java class next year. The computer science class there is taught a little bit more like a standard computer science course, so they have assignments that they have to do, there's, a flow, they go to lecture every day. It's not quite as exploration based, and they're also based in computer science as opposed to general technology where we weave through anything that sounds of interest to the students. And some students benefit from that, and you can see it in the work they do. And it really helps the other students grow when they see that knowledge come from another student.
Is there like cross-pollination between the two groups? Can you talk to the teacher?
So the teacher we have overseeing our club is actually the math teacher. So the question was, is there cross-pollination? And the answer is not a lot, because it's the math teacher, not the computer science teacher, who oversees our club. And it was just because the student who set our club up knew the math teacher and said, hey, will you oversee this club? I trust you. And then promptly graduated and left. So the result was a club that is kind of founded around this one math teacher, but that doesn't mean that we don't try hard to make sure our students can engage in the computer science lesson, and we definitely get some students coming in who can share the knowledge they learned in their traditional class with our club. Any other questions? Yes?
At the beginning, your slide showing things don't work.
Yeah.
I'm a software engineer myself. I think my daughter is in AP computer science now. But I think the school, the tendency to use the class, the things that you go to AP computer science class. It's not always fun. It's like learning syntax and just really drilling. It's not necessarily fun class.
So
this is a totally different animal than with my club.
yeah, so the comment for those of you on the remote feed is, well, a lot of the things you said don't work really are kind of how class is taught across the board. Sometimes it's computer science, but also most traditional study in high school is done that way. Lecture format, lots of assignments, it's hard to miss a class and catch up, and that's one of the reasons it doesn't work is we are an after-school program, and we just can't sell the students on, hey, you've got another class to come to. The students who want to take computer science that way will take computer science that way, and everybody else won't show up for our club. And so we have to do something different. It encourages learning by doing something different. It helps the students who have different learning styles than the traditional lecture-based format learning, and it really inspires students to come to an after-school club that's built around learning because we're doing something different than what they get in class all day. And I've been very careful to say, I'm not here to speak on the standard education style we do in this country. It works for some. I'm not convinced it works for all, but our club is made to be different because it is a club and students don't want more of that. But that doesn't mean that the lessons they get during school aren't also helpful for their lives. The teachers at San Marino High School work very hard, and we appreciate that we can do something different and still augment their education. Any other questions? Yeah, sure.
I know girls, they try to inspire girls to get computer science field, technology field. My sister both read at the same time. She was computer science. Drop off, become a computer programmer, right?
Mm-hmm.
So we lose probably 50% more women engineers, software engineers in the career. So I'm curious. How much success you have inspiring new grad alumni club to actually apply to computer science in a field college? Because of the inspiration they get a few years ago. But other people just taking classes, a lot of times when they apply for major, right? It's really at some point they got to feel that this is something I want to do. It's something I'm good at. I can do it. I want to do more. That would make me find it actually apply for it. I'm just curious. Do you have any success turning some of the girls in high school who may apply to a declared major, business major, actually resign major?
So I can answer that kind of twofold. For those of you on the remote feed again, the question is, how successful are you to get students to actually apply to college to do this? Because there's, a cliff where female engineers drop off, and that kind of starts in college sometimes. And the question is, how successful have we been at encouraging women from our club to join technology? And I'll say, first of all, San Marino High School has a lot of academic prowess, so a lot of the students that come through our club already kind of know what field they want to go into, and it's a lot of medical and science and technology. And so encouraging them to join computer science isn't necessarily our number one goal, because a lot of them are driven and know what direction they want to go, and the last thing I want to do is try to force somebody onto a different road when they already kind of know what they're looking for. So we want to encourage them to understand that they can do technology, because they will see it in the future regardless of if it's their major or not, and there we are successful. Every student that comes in learns something and feels like technology is more approachable. Now I will say, the first year of our club, we had a student who struggled a lot with computer science, struggled a lot with technology, and really struggled for 3 years in our club. But the fourth year in our club, that student graduated and said, I'm going into technology, I like this, and had started pulling apart separate lessons outside of our club because they wanted to continue to learn. So I can say some number of our students do in fact join the technology field and have in fact changed their course of direction to where they want to go. I just, as a mentor, don't want to force them to do that. I want to show them that technology is approachable and let them make the decision where it should fit in their lives. You had a question or a comment?
Yeah, that whole thing you talk about women getting into, priming the pipeline, right? But of course, the reality is there were a lot of women that aren't there anymore.
Mm-hmm.
So do you have any defense against the dark arts type classes? I guess are you addressing that issue of how this would be true for men and women? How to stay the course through sometimes what can be a turbulent career, a turbulent time.
So, kind of. Give me just a moment. The speakers we bring in every year who are female engineers in industry goes a long way because it shows the students that, yes, there are people like them out there. That's one of the defense against the dark arts, if you will, that we employ. And for those of you on the remote feed, it was a similar question of how do we protect our students as they go out into a world that can often be troublesome. So that's step one, is showing them that there's a path forward. And to that end, we also have started bringing in a mentor who's willing to show them that there are students like them just a year or so ahead. And so that female mentor who's there to really encourage our students and show that there's a path forward is another great defense. But the biggest defense we have is to show them that they can do technology. So that's the heart of my talk, was really how do we take these lessons and show them that they can do it. We remove that expert knowledge and instead we replace it by, yeah, it's just a couple of lines of code and there might be more going on behind the scenes, but the key piece, the brain, if you will, and not the plumbing, is done by you. And that is the best defense I can give them, is to show them that this is something they can accomplish. Because I remember going to college, I remember getting out there and saying, well, I've been fiddling around on my computer for a while, but there are these people who know how to do everything. Holy cow, I'm out of my league. And I did that, the same thing, when I showed up at JPL. But when I sat down and thought about it, it's like, oh, I'm still solving similar problems to them, but that jump is hard to make. And so if we can show them that, yes, you've done real things, you've controlled real robots. Yeah, it's a small robot, but it's a real robot. Yes, you've hacked through real computers. Yes, you've picked real locks. We have shown you that you can conquer this technology, and I'm always willing to take them through that plumbing. So if I have to do a couple hundred lines of code to support a lesson because we don't have time to type it all, I leave comments in everything, paragraph comments that would make most engineers say, oh, what are you doing? Why is there so much text there? Because I want them to be able to read that and say, oh, there's nothing special here. It's just he didn't want us to type 1,000 characters. He wanted us to type the 300 most critical characters in the program. And so to demystify technology by showing that it is approachable and possible is the best defense I can give them, because that's the thing that we see when we get to college. Even me, is you get there and there's all these know-it-alls who have been playing with computers forever, and they look at this program and they say, well, I just cached all this stuff in memory and did all this, and now my little microcontroller, which you got to show a pink screen on, the TV, now sings and has a font set and running an operating system that I wrote myself. This was my first year in college, and I'm sitting there thinking, I got the thing to blink, right? By showing them that technology is approachable, you quickly drive that fear out of them, because yes, somebody else might be further along, but we've demonstrated where that further along comes from, and it's usually they just, typed more, right? And so that's the best defense I can give them. And a lot of it comes from my experience being out of my league for most of my career and most of my college too. So that's why I leave them with so much success. That's why I put out a question bounty, because I want to show them, yes, I know a lot. I know a lot, and I usually come across as a braggart when I say I know more than them, because that sounds awful. But I'm always willing to walk them through every step of my thought process, or answer every question a little bit further down, until they understand everything. It might be at a high level, but they understand it all, and they know that there's no magic there. And that helps a lot, because then when they get out to college, it's not everybody knows this magic and I don't, and I need some defense for it. It's, oh, they've just been reading on their computer until too late at night. You had a question.
Yeah, so it's actually kind of a comment to what you're
Sure.
saying to kind of answer you too. So I am of,
And so the biggest thing for me when I first started was the same exact thing. I don't know anything compared to these people. And I did take, not cybersecurity, but IT classes in high school. And so I thought I was prepared. Maybe a year and a half into my degree, I was like, I still don't know anything. But what helped me personally to stick with it and stay with it was maybe just getting involved in our cyber organization that we have on campus, and also the Women in Cybersecurity organization. That way, I'm surrounded by people that help me.
Exactly what I'm talking about, like, are you telling them, hey, when you get out there, so I'm an engineer, and I've also been doing this for more than 30 years, and I started with compilers. So, but I will say that I see this a lot, like this gentleman who dropped out in real estate. People always go off into something that they can do really well, but trying to get ahead is difficult. And so I think telling them, hey, when you get out, like when I was in college, I didn't feel like I had any problems in college. College was awesome. But then you get out to the real world and you're like, why did that guy get that job and I didn't get it? Or how come I don't know any women who are, like CTOs of companies that they didn't start, right? I know a lot of women who just go out and they're like, fine, I'm not going to make myself my own company, right? And so, now that I'm married, I see my husband has very different expectations of his reception than I do. But I also see that he has very different experiences of, like, when he goes out to get a job than I do. And so I don't think that that's bad or good or anything like that. I'm not worried, but I do think that if you're going to stay through it, I think what you've done is fantastic. I mean, definitely, enthusiasm is great and passion is great. But there's also that practical, like what you're saying, like, join a group and have friends that can help you.
That too, but also the what we do is projects. So in order to kind of teach those skills that you don't learn in class, we do projects. So students will get together and basically just be project leads and research topics and teach it to anyone that wants to know. So we have stuff like ethical hacking, and we teach ethical hacking. And even once every other week do a lesson on something. So we do a lesson on social engineering or stuff like that. So it's basically, Grow to Code, but in the university.
So I just want to try to capture some of the discussion that we're having here in the room for the remote feed. I really don't know if anybody is still out there listening, but in case you are, the question that came up is, well, yes, some of this stuff works to defend students as they move forward, but the real experience is you get out there and the field seems to thin, and as you get into employment, the field still seems thin, and it's very hard to see, well, how do you compare to these other people in a realistic way, as opposed to a way where it's like, well, I'm not really sure what's going on here, or I don't really feel like I belong. And so one of the suggestions, which I will steal from you and start doing at our Girls Who Code, is to remind them and encourage them as they get into college to join student organizations. And I'm not deeply thinking ahead towards college because I'm mostly focused on teaching the students we have, but every year we do have an advice session with the seniors right before they graduate, and this year it's going to be a doozy because we have like 20 students who are seniors. And one of the things I will remember to encourage them this year is join those organizations, because that's what I did when I was in college, and I learned way more about a subject that I'm not qualified to do, which was Steel Bridge Team, and I'm a computer scientist. But the point is, when you join these organizations, it helps because you learn from projects, and these projects help you grow, and they help you grow much faster than just standard canned work. So for those of you on the remote feed, encourage your students to join clubs as they get into college, and encourage them to continue to seek out opportunities where that they can grow and other people in the world that they can learn from and grow from to continue exploring the field, even though it seems more and more daunting. Is that pretty much a synopsis of what we've discussed so far? I'm trying my best to capture it all for the remote feed so the people outside this room aren't left out. Are there any other questions, comments? And thank you for this discussion. It has been wonderful. It's the most questions I've ever gotten in a talk at SCaLE. Yes?
Just the silly one, the circuit, the copper tape, is that like soldering in class, or is it an electronic?
Oh, so a question on the paper circuits. The paper circuits is actually an adhesive with copper on one side. So it's really a roll of tape that is sticky on one side and copper on the other, which gives you this ability to just have flexible circuits that you can tape in any arrangement possible. And yes, I ordered it on Amazon. The one bit I can tell you is put the tape down and then put the lead on top of the tape and then put Scotch tape over it, because the adhesive on the back is only partially conductive. So if you put the lead on top, you get the full contact with copper, and you just put some Scotch tape on top. Did you have a question or a comment?
Just a comment.
Yeah.
In passing, you can do the same thing with toast and with Vegemite, because they have enough salt content in the
Interesting. Okay, so for those of you on the remote feed, I have just learned something, which is you can build a paper circuit out of toast and Vegemite, because there's enough free ions in the Vegemite that it can conduct. So I guess what? You put the toast down, run a trace of Vegemite, and then an LED and a battery? Okay, so note for the mentors in the room, we're doing this for Girls Who Code at some point this year, and so we're going to have to acquire some toast. Any other questions or comments? Otherwise, thank you for your time and thank you for your good discussion.